Hello everyone, very good afternoon to all of you. And yes, so I hope all of your midterm exams preparation is going on, and today we are here to revise the entire chemistry midterm portion in detail. I'll be telling you all types of questions, the most important questions that you need to revise at this point of time. Okay, so yes, let's get started here. Let's see if we have. Okay, so hello Rupashri, very good afternoon. So dear children, you can just comment me and tell me when is your chemistry midterm exam, like which date you have. You can let me know so that you just can plan how many days are left and all. Okay, so okay, hi, hello Akshay, hello Ganesh. So very good afternoon to everyone. Yeah, just a minute. Just let me know if I am audible to all of you. One second. Okay, so let me just check once again, my dear children, just a minute. Yeah, so I think everything is fine. So there are so many students already. Hi Digant, hi Alan, hi Ganesh, so hi Manvita, all of you. Austin, hi, very good afternoon. Yes, Akshay, 16th October, 8th October. Okay, so we have pretty well time to prepare. Okay, if you have on 8th or 6th October. Yes. Okay, so let's now dear start everyone. We will be starting, and we have just let's take a small voting here. Which section do you want to start? So I have taken here 6 chapters. Physical, first 2 chapters, solution and electrochemistry. Inorganic, 2 chapters, DNF block and coordination. And organic, 2 chapters, haloalkanes and haloarenes, and alcohols, phenols and ethers. So which section do you want me to start? Oh, Digant is having on 3rd October. So all the best, Digant. You have very less time. So please watch today's video completely. Then at least you can target 50, 60 plus. You can definitely target here. Okay. Okay. So Alan has given me comment for inorganic. I want other children. Manvita is also saying inorganic. Yes, students, do put down Ganesh for organic. Oh, Pano is having exam on 10th October. Okay, Akshay is saying physical first. So if I find random answers, then I'll go according to the chapter, like how the book is having the chapter, the same order we'll be following. Okay, so I have got now 3 votes for organic, 2 votes for inorganic, and 1 vote for physical. Yes. Okay, so I think by now I think organic is winning. Just some more votes we can see. 15th October. Okay, Rupashri, so you have enough time. Please watch the complete video of today. And students, the notes of this chapter will be provided to you. All the questions I have taken, almost I think 150 160 questions are there almost. Okay, so yes. Okay, so I think there are more votes for organic, so we will go with organic first. Okay, yeah, after first organic. Okay, Alan has found out the fault here. Fine, dear. Okay, let's go in this way. First organic, then inorganic, and lastly we'll come to physical. Okay, so let's begin here. First of all, one second. Okay, so we have before this. Okay, there are so many questions we have in today's session, and okay, so okay, first chapter in organic we have is haloalkanes and haloarenes. So do not worry, all the chapters will be completed. So first we'll start with organic, then inorganic, and then physical. Okay, so I hope that is fine. So first of all, if you see, this chapter has a weightage of 9 marks. Okay, so that means 1 marker you will get 2 questions, 2 marker 1 question, and 5 marker 1 question. Now this pattern will not be followed in your midterm exam. I'm talking about the board exams, because in midterm there are only less chapters, right? So that is why the pattern followed will definitely be different here. Okay, so now let's see the first 1 marker question. So I have taken certain 1 marker question. These are from your HOTS questions. Okay, so try to answer the first question here. Statement 1 is given. Enantiomers are non-superimposable mirror images on each other. Statement 2 is a racemic mixture shows zero optical rotation. First tell me the answer. Akshay, the notes will be given in our WhatsApp channel. Okay, yes. Now please give me the answer of this question. Okay. So both the statements 1 and 2 are correct. Statement 1 and 2 are incorrect. Statement 1 is correct, 2 is incorrect. 1 is incorrect, 2 is correct. So yes, both the statements are correct. I think all of you have given correct answer. Austin, it is both incorrect is wrong. Both are correct. Enantiomers, the definition of enantiomers is this one only, non-superimposable mirror images of each other. Now how do we show racemic mixture has zero rotation? Now listen, a racemic mixture has 50% of plus isomer and 50% of minus isomer, or D and L isomer. When you have 50%, what will happen? Suppose one isomer is rotating it in clockwise direction, another isomer will rotate it in anti-clockwise direction. As a result of which, what will happen? The net rotation becomes zero. That is why it shows zero optical rotation. Okay. Next, question number 2. 1,2-dichloroethane is an example of. So we have a structure like this. 1,2-dichloroethane is an example of alkylene dihalides, alkylidine halides, allylic halides, allylic dihalides, vinylic dihalides. Yes, students, whenever you are answering, please answer with question number. Okay, you have to put question number and then only you should answer, so that I can know that which question exactly you are answering. Kavana, Sagar, everyone please put question number and then answer. Okay, so yes, 2 question, this answer is alkylene dihalides. Okay, and this is also called as vicinal dihalides. Okay, vicinal dihalides. Then in alkylidine halides, this is called geminal dihalides. Okay, geminal means when you have on the same carbon 2 X groups are present. Okay, yes, very good Ganesh. Let's move to the third question here. 4 haloalkane compounds represented by letter M, N, O and P having boiling point are 24.2, 38, 3.56 and 101.6 respectively. Among 4 compounds, N most likely to be. Okay, so if you have M, N, O and P, okay, and their boiling points are what? Their boiling points are 38 degrees Celsius, 3.56 degrees Celsius, 101 degrees Celsius. Oh, I missed one more, sorry, just a minute. So we have M for 24.2, 38, 3.56 and 101.6, and you have 4 compounds given. These are the 4 compounds given. Okay, so now you know what is the rule for boiling point. When the mass increases, the boiling point will increase. Now if you see here, the mass is iodine is the highest mass, right? So that will have the highest boiling point. So which among this is having the highest boiling point? This one. So I can say that the C3H7I is P. Okay, next, which one will have the next boiling point highest? You can see here 2 carbon and bromine is there. This will have the next higher mass. So that is why here we'll be having the next highest boiling point. So N is the next highest boiling point. So here N will be C, or I can write here N, this was N. Next, if you see out of these 2, bromine mass is higher, so its boiling point will be higher. So this one will be your B, 24.2. That is CH3Br is your M, and lastly we have this one as O. Okay, clear? So which is N? The question asking N will be what? N will be option number C here. Yes, correct everyone. Next question, the homologous series of alkyl halides are represented by the general formula. Very simple question. What will be the general formula of alkyl halides? Alkyl halides general formula. Yes. Quick answer here. We know for alkanes it is CnH 2n plus 2. What happens here? One of the hydrogen is replaced with X. So we will have like this, right? So that is why option number A here. Okay. Yes, very good. Austin, great. Next, let's move to the fifth question. Toluene reacts with a halogen in the presence of iron chloride, giving ortho and para halo compounds. The reaction is. So we have a question like this. Toluene is reacting with what? Toluene is reacting with halogen in the presence of iron chloride. Okay, giving ortho and para halo compounds. So the reaction is. Now here if you see, this is an electrophilic substitution reaction. We have studied that electrophilic substitution reaction. So option number B here. 5 is B. Yes, I want everyone to answer whether it is wrong or correct. All of you attempt the question, then only you can know like where you are actually going wrong, which questions are wrong, which questions are correct. So please attempt the question, put down your answers in the comment section. I can see only few students answering here, so I want everyone to answer. Okay, let's move forward. 2 marker question. Now there is something to discuss here in section B. Okay, section B, you will get one like 2 marker question will be asked from this particular chapter. Okay, so let's see what are the possible 2 marker questions that you can get. So first of all, there are name reactions. All the name reactions you have to remain. What's reaction if that is asked? How will you write? Whenever a name reaction is asked, you have to mention first is the statement. Okay, statement, and you don't have to remember any bookish language to write the statement. What 3 things you have to mention in the statement? Reactant, okay, reactant, product and reagent. These are the 3 things you need to write in the statement of the any name reaction. So for example, in Schwartz reaction, what happens? The alkyl chlorides and bromides gives you alkyl fluorides in presence of metallic fluorides. So you can simply write that alkyl chlorides or bromides react in presence of metallic fluorides to give you alkyl fluorides, and then you have to just write one example. Okay, so any name reaction always follow the same path. Clear? So what I will get here, you can see the answer here. We have alkyl fluorides are synthesized. So I have written a big answer. You don't have to write this much. Simply you can write down the like reaction and the final product here, right? Just note down this question. You have to note down all the questions, or you can take the screenshot. I'll also give you the PDF, so don't have to worry. Just need to put this, and then you have to practice these questions. Okay, definitely you can score more than 50 if you practice these questions. Moving to question number 2. Chlorobenzene cannot be prepared by reacting phenol with SOCl to give reason. So this is, you can see this question is from sample question paper 2 of 2025. Now as we see, Rx is there. Okay, Rx is there, and when you react with SOCl2, we get RCl plus SO2 plus HCl, and we say that this is the most preferred product also. Now if you have simple, instead of Rx, if you have this benzene ring with X and you are reacting with SOCl2, then you will not have, sorry, here it is ROH, right? If you have ROH, and similarly if you have here phenol, that is OH, okay, and then if SOCl2 is there, then you won't get here chlorobenzene. You won't get this product. This reaction does not happen. So the question is asking you, why is this? Why this reaction is possible whereas this reaction is not possible? Can you just put down the answer in the comment section in short? What can be the reason for that? In short, I'll show you the answer. Yes, Pooja, hi. Okay, so first of all, if you see chlorobenzene, see how I have to tell you, the answer is very simple, that when you have this phenol group, right? When I have this phenol group, this phenol is having what? It is having resonance with this, right? So this bond is very strong and it is difficult to break this bond. So that is why direct nucleophilic substitution reaction does not take place. So what is the main answer highlight point here? That chlorobenzene cannot be prepared from alcohols, as the carbon-oxygen bond in phenols has a partial double bond character and is difficult to break. That's what you have to mention. Okay, clear? Next, I hope this answer, if this answer is clear to everyone, please put a thumbs up that the answer is clear, then only I'll go. See, if you have understood the concepts, you can write any answer, don't have to worry at all. So do let me know if the concept is clear. Okay, next we have explain fatigue reactions. Okay, so again, name reaction, same thing you have to follow. What is fatigue reaction? In fatigue reaction we have Woods reaction, fatigue reaction and Woods fatigue reaction. In fatigue reaction what we do, we take one ARX plus ARX, okay, and then you get one AR and AR, right? This is the reaction for fatigue reaction. So the same thing you need to write, okay. Aryl halides, yes Pano, after haloalkanes I'll be going for alcohols, phenols and ethers also, don't worry, okay. Next is fatigue reaction. Very quickly we can explain. Aryl halides when react with, so the same thing, I'm not going in detail, you can just check the question, I'll just discuss whichever questions are difficult, okay. This is simple question, direct question, you have to write the definition and then you have to write the equation, okay. Next we have question number 23. Complete the following reaction and name the reaction, okay. This was the question that was asked in 2024 midterm paper. Now you have to find the product here and the name. So can you answer this question? Can you answer this question? I want this answer, very very simple answer. Can you answer this? Okay. Yes, let me see who can answer this question. Yes, very good, Austin, very good. Can you tell me the product also? Can you tell me the product also? What will be the product and what will be the name of the reaction? Yes, I have found Austin has given me the correct answer. The name of the reaction is definitely Finkelstein reaction, okay. And we have here one more, okay. Then we have here the product will be Ri, okay. Ri is the final product, right? Any doubt here? Okay. Next, let's move to question number, this was the question that was asked in final PU2 of 2025 board exams, okay. Explain Woods reaction with a suitable chemical reaction. Again a name reaction. In Woods reaction what we have to take? You have to take Rx plus Rx, right, in presence of sodium diether, okay, and that will give you RR, right. So just you have to explain here, two alkyl halides reacts in presence of sodium diether to give you alkanes, okay. So I have written this and then you can write down any example here, okay. Yes, very good my dear children. Let's move to the next question. So now I have taken certain 2-marker questions from PU2 question bank, okay. So one of the most repeated question is the difference between SN1 and SN2. Here so many points I have given you, you have to just remain 3 to 4 points will work, okay. So yes, Kavana, you are correct. So just 3 to 4 points, okay. 3 points if you remember, that is enough. The first point is definitely, what is the first point you should be writing? I'll tell you, it follows first order kinetics, sorry, yeah. 1 second, yeah. It follows first order kinetics, it follows second order kinetics. Next, mechanism of SN1 reaction involves 2 steps and here it involves only single step, okay. Rate of the reaction depends on concentration of substrate only, it depends on concentration of both substrate and nucleophile. Here there is carbocation is formed, here no carbocation is formed. So any 3 points of this you can write down, okay. Thank you Royson, thank you so much. Let's move to the next question. I want all of you to answer this question, okay. Which alkyl halide from the following pairs would you expect to react more rapidly by an SN2 mechanism, okay. So this is suppose 1A and this is B and this is 2A and this is B, okay. So you have to write the answer like this. You have to put question number 7, 1, whether it is A or B, okay. And here we have 2, again here you have to write A or B, okay. Just put down this answer quickly. Yes. So 1 second, yeah. So which one will react faster with SN2 mechanism? And if you don't know the theory behind that, let me just tell you. In SN2 mechanism, the order is 1 degree, 2 degree and 3 degree. Okay, 1 degree, 2 degree and 3 degree. Now I think you can answer. Yes, yes, very good. So you just need to tell me whether it is A or B here. A or B. In 7th question, 1, okay, this is 1, A or B. Which one will be reacting more faster? Yes, Royson, very good, A. So this is, if you see, this is a primary alkane, right? Primary haloalkane, so it will react faster. So this is the answer. Next here, out of this is tertiary, so it will not react. This is also primary, this is also primary. Both are primary actually. So in case when both of them are primary, you have to see the steric hindrance. Okay, wherever there is less bulky, okay, wherever there is less bulkiness is there, that will react faster. So here you can see, if I draw this structure, the first one, it is like this, C, okay, C, 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 then you have CH2, Br, okay, and then you have C2H5, Br. Okay, now you see here there is so much bulkiness is there, right? So this one will not react, this one will react faster. So here also it is A, here also it is A. Okay, clear? Yes, Akshay, definitely you can get. Okay, yes. Next let us solve some fill in the blank step question. Here there is a reaction A plus Na gives like with dry ether, you are forming this product. You have to guess what is A. Okay, so let me just write down this reaction for all of you. So it is like there's a dash, and with sodium and dry ether, with sodium and dry ether, you are getting a product like this. I'm just writing carbon, okay, plus NaBr. Okay, so now you have to guess what would have been this one, so that we are getting. First tell me this is which reaction. Tell me the name of the reaction first. Name of the reaction. All of you tell me the name of the reaction first. Quick. Yes, Royson is very good, very active. Wood's reaction is correct. Yes. Next you have to tell me what has to be A here. What has to be A here? Wood's reaction is basically, see how will you find the product? Wood's reaction product is double of the reactant. Means if you just make it half, that will be the reactant. So if I break it like this, then I'll get here like this. Okay, so this one is my reactant for this A. Now here if you see this is bromine, this X has to be then bromine. Okay, that is A. Next here, this is a reaction from your polyhalogen compounds topic. So this is CHCl3. Chloroform, if you react with oxygen, we get a poisonous compound called as phosgene. Right? Okay. Next, with the help of a chemical reaction, show that the presence of electron withdrawing group fastens the nucleophilic reactions of haloarenes. So this is very, see, so what happens here is, if you have a, I can say any X group, okay, now this reaction to a nucleophile, okay, when a nucleophile tries to react with haloarene, okay, this reaction is not favorable. Now what is the reason for that? We have three reasons you should be remembering. This is a partial double bond character, first reason. This is sp2 hybridized carbon, second reason, and third reason is the instability of the phenyl cation. Now what happens here is, basically if you understand, this ring itself is nucleophile. It's a nucleophilic reason. Why? Because X is donating electron, it is increasing the electron density, these pi bonds are present, so that also makes the ring electron rich. So a nucleophile will not react with another nucleophile. So what happens is, we can increase this rate of reaction if I add what? Electron withdrawing groups. Okay, if I add electron withdrawing groups, then this reaction will be possible. So I'll show you, we have this example given in the book. So you can see that when you're reacting only chlorobenzene with NaOH, you will get only 623 K 300 atm at such a high temperature and pressure. The reaction is possible. Now when you take NaOH at 443 Kelvin, means if you add one NO2 group, the reaction can now be possible at 443 Kelvin. Now if I add two NO2 group, the reaction is possible at 368 Kelvin. Now when you add three NO2 group, the reaction is even possible with warm water. So you just need to show this reaction. Okay, please take a screenshot of this one. Okay, yes, fine. Yes, study for your success. Today's session questions are more than enough. Okay, let's move to now 5-marker question. So this question was there in sample question paper 1 of 2025. Write the mechanism involved in the conversion of 2-bromo to methyl propane. Okay, so if you have 2-bromo to methyl propane, okay, to 2-methyl propane 2-OL, you want to convert it to 2-methyl propane 2-OL, right? So just tell me by commenting that whether it is SN1 reaction or SN2 reaction. Quickly tell me whether it is SN1 mechanism or SN2 mechanism. Yes, tell me, is it SN1 or SN2 mechanism? Yes, Austin, very good. SN1 mechanism, right? So SN1 mechanism takes place in 2 steps. So you have to write both the steps here. So I'll just show you how to write. So this is there in first step. What is there? Step 1 is formation of carbocation. Okay, so we get a carbocation here. The second step is attack of nucleophile. So you can just, while writing, you can write the heading also. So what is step 1 here? Formation of carbocation. And what is step 2 here? Attack of nucleophile. Okay, so you need to write both the steps here. So that will give you 3 marks. Okay, this, if you write all the reagents and everything, leveling properly, so that will give you 3 marks. Next, what are enantiomers, and name one physical property which differs the enantiomers. So we have seen what is enantiomers. Enantiomers are stereoisomers which are non-superimposable on each other. Okay, they have non-superimposable mirror images. Next, which property is different in case of enantiomers? So generally, enantiomers have all the physical properties same, but there is one physical property which is different in enantiomers. What is that? The side in which they rotate the plane polarized light. So always a enantiomer pair will have one plus and minus. Okay, the plus one will rotate it in clockwise direction, and the minus one will rotate the plane polarized light in anti-clockwise direction. Okay, so what is different in them? The only different is with respect to the rotation of plane polarized light. Clear? Yes, Roshan, you are absolutely correct here. Now let's move to the sample question paper 2. There was one question of 5 marker. First of all, you have to write the product here, HBr. So when I add HBr to this one, which rule it will follow? It will follow Markovnikov's rule, right? So Markovnikov's rule tells that the negative part will go to the carbon having less number of hydrogen, right? So if you see this carbon and this carbon, so if you see this carbon has 2 hydrogen and this carbon has 1 hydrogen. So what will happen? This bromine will come and join here. So what will be the product I'll get? You will get, and this H will attack here and bromine will attack here. Okay, so what I will get? You have CH3. Okay, next I have CH3, H and Br. Okay, so that will be the final product. Next, again I told you Na dry ether, this is what? Woods reaction. So you have to just divide it into half. So you'll get a product like this. Okay. Next, NaOH at 623 and 300 atm. Just now we have discussed at a certain temperature what will happen? This Cl minus, this Cl group can be replaced with OH group. So this will be the product here. Okay. Next, what is Saitsev rule? Explain with an example. So let us first discuss this one quickly, then we'll go for the answer. So now see, suppose you have an X group here. Students, any doubt you have, you can just put down in the comment section. Okay, I'll be answering to all your doubts as well. Okay, now see, suppose this is a haloalkane I have. Now what I'll do is I'll take a base here. Now what will base do? Base will abstract a proton. So there are two protons. Now the carbon which contains the X group is called as alpha carbon. The carbon beside to it is beta, and this carbon is also beta. Now what will happen? This OH minus will abstract the beta hydrogen. So how many beta hydrogens are possible? There is one possibility for this hydrogen, and there is one possibility of this hydrogen. So if this hydrogen extracted, there is a double bond formed here. If this hydrogen is extracted, there is a double bond formed here. So what are the possibilities? What will be the product in this case? In this case, you will get CH2 double bond CX. You have CH2 CH3. Okay, just a minute. Okay, so X will also go, right? No X is there because double bond is formed here. Yeah, so this is one product formed here, and there is another product also. What will happen when you take this H? So X will be removed and we'll get a double bond here. So I'll get CH2 C double bond CH CH3. Okay, so this is one product, this is one product. So you can see that Saidzev rule says that whenever you have a double bond where there are more number of carbons around the double bond, that is more substituted, and that is the major product. Now here if you see around this double bond there is only one carbon, but around this double bond there are both sides carbon are there. So this is more substituted and this will be the major product. That is what Saidzev rule says. So how can we write it in the answer? So you can see in dehydrohalogenation reaction, okay, dehydrohalogenation, removal of one hydrogen and a halogen, the preferred product is that alkene which has greater number of alkyl groups attached to the doubly bonded carbon atoms. Example here is taken 2-bromopentane. There is a two possibility. You can get here one alkene and you can get here also. But yes, this is the major product according to the Saidzev rule. Okay, is it clear? Yes. Royson, it will go up to at least 2 to 2.5 hours the class will go, because we will complete all the chapters, right? Yes. Now let's write any three difference between SN1, SN2 that I have already discussed. I have given you so many points. You can write any three. Identify A and B in the given reaction. So can you tell me the name of this reaction? Can you answer the name of this reaction? Yes. Can you tell me the name of this reaction? Name of this reaction. So this is Sandmeyer reaction, right? And here if you see what will be A formed, A will be your benzene disonium chloride. Okay, this is benzene disonium chloride. Then when you take A and B, what you have to take? You have to just take Cu2 Br2 and then bromine will be added here. Okay, moving to the next question. So there is a question in half yearly of 2024. Write any three differences between SN1, SN2 that we have already discussed. What is racemic mixture? Give an example. Now racemic mixture is a mixture which contains equal proportions of both the enantiomers, right? So you can just write down a mixture containing two enantiomers in equal proportions which have zero optical rotation, as the rotation due to one isomer will be cancelled by the rotation due to other isomers. Such a mixture is called as a racemic modification or mixture. Example, you can write plus minus butane 1-OL. Okay. Next question, we will move to half yearly 2024. There was one more question. Okay, yes. Write the chemical reactions for the following conversion. Can you do this? We have chlorobenzene, and what I should add here so that I get ethyl benzene. This was a question in midterm 2024 and can be asked in this year also. What will be the reactant that I can use here? Yes, which reactant can we use here? Yes, thank you, Raisen. Thank you so much. We will be continuing all the chapters we'll do today. Okay, Ramse will do slowly. Yes, yes, but I want everyone to participate in the answer. What can you think here? What I'll give you a hint. It's a name reaction. It's a name reaction. Okay, have you heard of this reaction? Woods-Fittig reaction. In Woods-Fittig reaction, what I take? You take Rx plus ARX to get what? ARR, right? So I already have this ARX, and if I just mix that with C2H5Cl, then what will happen? These two will form a product and this two will react, and I'll get this one. So what is here? What I have to add? This one in presence of Na dry ether. Okay. Next, ethanol to chloroethane. If you have ethanol, if I have ethanol to chloroethane, in n number of reagents you can use, just give me one reagent that I can use here. Yes, one reagent that I can use here for ethanol to chloroethane. Any one reagent you can tell me that I can add here to get the... We have so many things, right? The best one here we can write, that is SOCl2. Okay. Next, name the freon manufactured from tetrachloromethane by Schwartz reaction. So it is CCl2F2 and it is called as freon 12. Okay, freon 12. Fine. Okay, let's move to the next question here. This question was actually asked in PU2 2025, the actual paper. Write the SN2 mechanism for the conversion of chloromethane to methanol. Mention its order. So if you remember, chloromethane, CH3, you have to convert chloromethane to methanol. Okay, so this is a SN2 mechanism. SN2 mechanism is which order? In SN2 mechanism, the nucleophile and the reactant, or I can say haloalkane, both are present during the reaction. So it is a second order reaction. Okay, this is a second order reaction. Now what will happen? Just a mechanism. So OH minus and this one reacts together, it attacks here, and then this thing is formed which is called as a transition state. Okay, a transition state is formed, and then finally we'll get a product here, that is this one plus Cl minus is formed. Okay, so that is your mechanism. You write three things, you will get 3 marks here. Next, what is racemic mixture? Already I have explained this answer. Represent the butane 2OL in the racemic mixture form. So this part is important. How to represent? You have to represent plus minus butane 2OL. Okay, that is the representation of racemic mixture. Yes. Good. Next we'll move to second chapter, that is alcohols, phenols and ethers. Now those students who were waiting for this chapter, please come quickly and let's start discussing the next chapter, that is alcohols, phenols and ethers. Okay, so alcohols, phenols and ethers has total weightage of 10 marks in the final board exams. You will have 3 MCQs, 1 short answer question and 1 5-marker question. So 5 plus 6, 7 plus 3, 10. Okay, so I have here 1-marker questions. The first question, please all of you try to answer. Propene is allowed to react with HBr. Okay, you are taking propene. Propene is allowed or treated with HBr in presence of peroxide. Okay, so what will be the product here? What will be the product here? Yes, Pano, we are now at alcohols, phenols and ethers. So students, please share this video with all your friends so that everyone can revise. You can also revise with your friends. So please share this video and let everyone join this session and let everyone talk about, just discuss these answers, and let's have a group study here. Okay. Yeah, Pano, since that is why we will be discussing this chapter in detail in this live session. Okay, so since there are less days left for the exam, so we have directly shifted to live. But yeah, we will try to add that also. But in here also you will get details, discussion of questions for this particular chapter. Okay, let me have some water and then you can all answer this question. Yes. What will be the answer for this question? HBr with peroxide. Do you remember? It is anti-Markovnikov's rule. Anti-Markovnikov's rule means negative part will go to the carbon having less number of hydrogen, right? So Br, if you see, sorry, anti-Markovnikov rule says that negative part will go to the carbon having more number of hydrogen, right? So if you see here, I have CH2 and here I have H, right? Which is having more number of hydrogen? This carbon is having more number of hydrogen. So bromine will attached here. You will get CH2, Br, CH2, CH3. So what is it? This is 1-bromopropane. Okay. So what will be my answer here? Okay, after this what we have done, and the product is subsequently treated with aqueous KOH. Okay, after that you are treating it with aqueous KOH. So what will happen? Bromine will be replaced with OH group. Okay, so I'll get here which product this is. This is 1-propanol, option number C here. Yes, very good. Next, the ether C6H5OCH2 C6H5 on heating with concentrated HI produces. So you have a compound like this, okay, CH2 C6H5. Okay, so if this is there, now what will happen? You are treating with HI. Now always remember one trick here. If there is a phenol group, if there is a phenol ring or benzene ring and then there is an oxygen, every time the bond will break like this and H will come here. That is, every time this rule is followed. So never do this mistake. Whenever you have an oxygen attached to benzene ring, just break the bond and add here H, and this side you have to add I. So what I will get here? I'll get one product is phenol and another product is, I'll get CH2I, and this side it is phenol. Okay, so which option is this one? Yes, that is option number C here. Yes. Next question, let's move students. In the following compounds, the acidity order is. You have acidity order, so always remember, if you have electron withdrawing group, the acidity increases. Okay, if you have electron withdrawing group at para position, then acidity will increase more. So if I see all these four compounds, there is no electron withdrawing group here. This is an electron donating group. So vice versa, what will happen? Electron donating group will decrease the acidity, right? So this one will decrease. Here I have one NO2 group and here also I have one NO2 group. These are electron withdrawing groups. So they will increase the acidity. But what happens? I told you at para position, the effect will be more pronounced. So D will be, or I think the fourth compound will have the highest acidity. There's only one option like with that. So option number D here. No, Kavana, C is not the correct answer. The one electron donating group will have the least acidity. Electron withdrawing groups will have the highest acidity. Both of them are having electron withdrawing groups, but at para position the electron withdrawing group is more pronounced or more effective. So that is why fourth will come, then we will have 3, then we will have 1, and lastly we have 2, because that is an electron donating group. Okay, just let me know if this concept is clear to everyone. Next question, in which of the following reactions phenol is not obtained? So this reaction you can easily see. Here we can obtain phenol reaction with decarboxylation reaction. Here also we can obtain. Here we have N2Cl plus warm water. This is also there, but you cannot replace a Grignard reagent like this because this bond is very strong. So that is why option number B here. Okay. Next, question number 5. Phenol is a weaker acid than acetic acid because. So if I have acetic acid, okay, and I have phenol, what will happen? Both will lose 1,1H plus. So I'll get CH3COO minus, and here I will get O minus. Okay. So in both the cases, what will happen? In both the cases, what will happen? You will get, the question is saying that this is more acidic than this one. The reason is, so when we talk about acidity, is always about the stability of conjugate base. Stability of conjugate base. So obviously this one is more stable than this one. Okay. Phenoxide ion is better stabilized? No. Acetate ion is better stabilized? Yes. Because of what? It has, why it is more stabilized? Because of equivalent resonating structures. Okay. Phenoxide ion has more resonating structures than acetic acid or acetate ion, but acetate ion has what type of structures? Equivalent resonating structures, which is why it is more stable. Okay. Yes. Now let's move to 2-marker question here. Okay, let's move to 2-marker sections. Write the reaction involved in the preparation of phenol from cumene. This question was asked in sample question paper 1 of 2025, a very, very important question. Cumene, you can know this reaction you have to write. You have to add oxygen, then you will get cumene hydroperoxide, and then if you take H plus and water, you will get phenol and acetone. Sometimes this byproduct is also asked, so this is also important. Okay. Next, moving to sample question paper 2 2025, there was a question, explain the preparation of methoxyethane by Williamson synthesis. So just let me talk about this one. Williamson ether synthesis is used for the preparation of ether group. Ether group is like ROR. Okay. Now what are the reactants you take here? You take one RX plus R-ONA. Okay, a sodium ethoxide and an alkoxide. Sorry, one sodium alkoxide and an alkyl halide. And always you should remember that this one should be a primary alkyl halide. Okay. Now when these two react, what you will get? You will get R-OR. Okay. So that is what is all about Williamson ether synthesis. So now the question is asking you to prepare methoxyethane. Okay. So one should be your alkyl halide, another has to be one alkoxide ion, sodium alkoxide ion. So the one which is less hindered should be your methyl halide. So you should take CH3Cl plus CH3CH2ONA. If these two will react in presence of sodium and dry ether, not dry ether is not required here, sodium is also not required, just a normal reaction. If you take this one, what you will get? From here you will get CH3, and from here you will get OCH2CH3. Okay, that will be the product here. Okay, next let's see. Yeah, next question. Okay, next question, complete the following reaction and name the reaction. So this was sample question paper 3 2025 paper. Okay, here you know this product will be your, with a phenol ring you have a CHO group. Okay, and this reaction is called as Reamer-Tiemann reaction. Okay, this is the Reamer-Tiemann reaction. Next is your midterm paper question. How do you prepare alcohols by reducing carboxylic acid and write the general equation? So carboxylic acid, if you treat with a reducing agent like lithium aluminium hydride, you will get alcohols. Okay, and the general reaction is like this: RCOH plus LiLH4 gives RCH2OH. Okay, you can write down the reaction here. Next, there was another question in the midterm paper. Write the chemical reaction for the following transformation. Very good question. Butane 1-OL to butanoic acid. So whenever you want to convert primary alcohols to acid, okay, you have to use a very strong oxidizing agent. You can use KMNO4 or K2Cr2O7. Okay, so what's the answer for the first one here? The first one answer is KMNO4, or you can also use K2Cr2O7. Okay, next, cyclohexene to adipic acid. This is important. Here also you need to use this reaction, cyclohexene to adipic acid. You have to use KMNO4 with dilute H2SO4 and some amount of heating here. Okay, moving to the next question. So this is the PU2 2025 actual question paper. The question was asked, while separating a mixture of ortho and para-nitrophenols by steam distillation, name the isomer which will be steam volatile, means which one will be easily volatile or easily evaporate, and give reason. Can you answer this? I want the students who are live here to try to answer this question. Yes. Try this question. Anyone can answer to me? Okay, so this one is your steam volatile is orthonitrophenol. It is steam volatile, and the reason is because of intramolecular hydrogen bonding. Okay, next we'll have some 2-marker question. What is esterification reaction? Given example. Okay, so you have here esterification reaction and you have to find one example for that. So esterification reaction is the reaction between, you have ROH plus RCOOH. Okay, when you react these two, we will get one ester group, that is RC double bond O OR. Okay, so this reaction is called as esterification reaction. You can write down here like this the answer. The reaction between acids and alcohols in the presence of concentrated H2SO4 to form esters is called esterification reaction. Okay. Now, what is Lucas reagent and how would you distinguish between primary, secondary and tertiary alcohols by Lucas reagent? So, this is very simple question and it is a question that is very, very important. Okay. So, now, okay. So, now let's see the next question. Any doubt you have? Yes, orthonitrophenol is steam volatile, that is correct. So students, just let me know. I'm going a little bit faster here now because we have a lot of things to complete. Okay, so if you have any doubt in any question, you can just put down. I'll wait and I'll explain you. Okay, so Royson, very good, you are correct here. Anhydrous ZnCl2 plus concentrated HCl, that is Lucas reagent. Now, how is that used to distinguish between primary, secondary and tertiary alcohols? So primary, tertiary alcohols, when you add this Lucas reagent, so what exactly we do? We take ROH, right? Then we add HCl and ZnCl2, anhydrous ZnCl2. So what I get here is RCl. Okay. Now this RCl which is formed is soluble in the solution and it creates a turbidity. Okay, it creates a turbidity. What do you mean by turbidity? Means the solution becomes slightly diluted, means it is not visible properly. A dense type of thing is formed here. Now, how can I, from this reaction, how can I know whether this alcohol is primary, secondary or tertiary? So here is the thing. If the turbidity is formed immediately, then it has to be a tertiary alcohol. If the turbidity is formed after 5 minutes, then it has to be a secondary alcohol. If the turbidity is not forming at all, means no reaction, then it has to be a primary alcohol. Okay, that is how you can distinguish. Yes, very good, Roshan. I want other students also to participate, to write down something in the comments so that I can know whether you are understanding or not. Okay, so now let's see here. So I have given a bigger answer. A mixture of anhydrous ZnCl2 and concentrated H2SO4 or HCl also you can write here is called Lucas reagent. Alcohols are soluble, so this one is not required. In case of tertiary alcohol, this is important. Turbidity is produced immediately. Secondary alcohols after 5 minutes, and for primary do not produce. Okay, these three are important how to distinguish. Now let's move forward to the next question. What happens when vapors of copper, vapors of primary, secondary and tertiary alcohols are passed over heated copper at 573 Kelvin? So here it is important question. So if you have primary alcohol, secondary alcohol and tertiary alcohol and you react with copper at 573 Kelvin, so what will be the products formed here? Okay, so primary alcohol will give you what? Aldehyde. Secondary alcohol will give you ketone. Tertiary alcohols will give you alkenes. Okay, so now what I'll do, you can just see here. Primary alcohol aldehyde, secondary alcohol will give you ketones and tertiary alcohols will give you alkenes. You just need to write down this much. Okay, when the vapors of primary or a secondary or tertiary are passed over heated copper at 573 Kelvin, dehydrogenation takes place and an aldehyde or a ketone is formed while tertiary alcohols undergo dehydration. Okay, clear this one? Yes, very good. Next we have, how do you prepare aspirin from salicylic acid? Give the IUPAC name of aspirin. Very, very important question. How do you prepare aspirin from salicylic acid? So this is an esterification reaction. So salicylic acid, salicylic acid reacts with acetic anhydride in presence of concentrated H2SO4 to give you aspirin, and its IUPAC name you should be knowing. So this is salicylic acid with acetic anhydride. What will happen here? Esterification reaction will take place, and you will get this is already an alcohol plus anhydride will react, and here you will get one ester formation. Okay, this is called as aspirin, and its IUPAC name is 2-acetoxybenzoic acid. So this product is acetoxy group, so 2-acetoxybenzoic acid. Okay, yes, very good, my dear children. Yes, so hi Akash, good evening. Then we have Kavana, good afternoon, sorry, Roshan. Yes, so students, please do answer the questions. Any doubt you can put down in the comment section. Okay, next we have explain Coles reaction, or how do you convert phenol to salicylic acid by Coles reaction. Name reaction, again I have told you in the starting how to write the name reaction. You have to write the statement and then the general reaction. So in Coles reaction, what we have, you have sodium phenoxide which reacts with carbon dioxide followed by acidification to give you salicylic acid. Okay, so you have here sodium phenoxide reacts with carbon dioxide to give you 2-hydroxybenzoic acid or salicylic acid. Okay, name reaction you should be preparing. Next, similarly you have Riemann-Tiemann reaction also. In Riemann-Tiemann reaction, we have phenol on heating with chloroform. It gives you what? It gives you salicylic aldehyde, or we call it as benzaldehyde. Not benzaldehyde, salicylic aldehyde. So you have phenol here with chloroform. You will get this intermediate which is called as benzyl chloride. Okay, and then this gives you salicylic aldehyde. Okay, so students, for name reaction I'm not going in detail. This is what you have to remember, the statement and the reaction. Now moving forward, we'll go to 5-marker question. So the first 5-marker question is from the model question paper of 2025. Okay, I hope it is visible. Yeah, write the reaction involved in the mechanism of acid catalyzed dehydration of alcohols to alkenes. So if you see, you have alcohols. Okay, so first what will happen? H plus is there. H plus will get, or this OH will get protonated, and you will get a compound like this. Okay, this is step number 1. In step number 2, what will happen? This protonation, the protonated water will be moving out. Okay, it will go out, and here there will be a carbocation formed. Okay, now in step 3, what there will be? In this carbocation, what will happen? Now you are involved in the acid catalyzed dehydration of alcohol to alkene. Yeah, next what will happen? There will be this H is there which will come here, and then you will get an alkene produced here. Okay, so this is the basic step. Step number 1 is protonation of OH. Step number 2 is the removal of water, or you can write formation of carbocation. Step number 3 is deprotonation or removal of this proton and formation of alkene. So I'll show you how to represent it in the answer. So the first one here, protonation of alcohol. Second step, slow step, here there will be removal of water or formation of carbocation, and after that there will be you can say elimination of proton, and you will get an alkene here. Okay, that's the first question. Explain the preparation of anisole by Williamson ether synthesis. Anisole, so we have just discussed now. Okay, just a minute. So what is anisole? Anisole structure is like this. Okay, so you have to take an Williamson ether synthesis. So I can take CH3X plus this one with ONA. So what will happen? This O minus will attack on this one, and you will get a compound like this, that is OCH3. Okay, this is Williamson ether synthesis. Yes. Next, model question paper 2 of 2025, there was a question. An alkene X, so there is one alkene X which is having C3H6, okay, reacts with H2O and H plus to give you compound Y. Reacts with H2O or H plus to give compound Y. Now Y further undergo reaction with CrO3H2SO4. Okay, Y further undergoes CrO3H2SO4 to form compound Z, and you have to write the IUPAC name of X, Y and Z. Can anyone try this question and tell me? At least can you try for X, Y? When you add water to C3H6 in acidic medium, what will happen? Try this question. Yes. Anyone? Okay. So first there will be so C3H6 is like this, right? Markovnikov addition of water will take place, as that means the negative part here H plus is there and OH minus is there, right? OH minus is the negative part. Here I have 2 carbon, here I have 1 hydrogen, and here I have 3 hydrogen. So OH minus will go to the carbon having less number of hydrogen. So OH will attach here. So what I will get? CH3 COH, and you have CH3. Next, when you oxidize it, what will happen? This one will oxidize to give you propanol. Okay, so I'll get propanol here. So what is the IUPAC name of X? IUPAC name of X is propene. Okay, IUPAC name of this one is propane 2OL. And then you have this one, that is propanol. Okay, propanol. Clear? So what will be the answer? Next question. So this one is clear to everyone. Okay, next question. Which among the following compounds have the lowest and the highest pKa value? Now here you should remember, lowest pKa means what? Highly acidic or strong acid. Okay, and highest pKa means weakly acidic or weak acid. Okay, here it is strong acid and here it is a weak acid. And strong acid means, so what should strong acid should have? Strong acid should have a electron withdrawing group, and here we can have a electron donating group. Okay, so now we have paranitrophenol, phenol, ethanol and cresol. So first of all, you should remember the very basic thing, that is alcohols are less acidic than phenols, right? So here I can find that I have one alcohol, ethanol, okay, and all others are part of phenol group, means phenol with some substituents. So definitely alcohol will be least acidic. Least acidic means it will have the highest pKa value. So it is ethanol. Okay. Next we have the lowest acidic, means lowest pKa value means highest acidic. So here I have an electron withdrawing group, nitro group is present. So that is why this one will have the highest acidity or lowest pKa, paranitrophenol. Any doubt in this question? Tell me. If you have any doubt, anyone in this question, tell me. Is it clear? Put a thumbs up everyone if it is clear to all of you. If this question is clear, please put a thumbs up. Okay, I am moving to the next question. Give the mechanism involved in the acid catalyzed hydration of alkene to alcohol and name the enzyme involved in the fermentation of glucose into ethanol and write its chemical equation. This question was asked in model question paper 3 of 2025. Okay, so first of all, mechanism of acid catalyzed hydration of ethene to ethanol. So that you can see here, first of all, what happens? In step 1, the alkene get protonated, okay, and there's a carbocation formed here. Next step, what will happen? Nucleophile will attack the water, water will attack at the carbocation and you will get a compound like this. Then deprotonation will take place again. This H will go from here and you will get an alcohol here. Okay, this is clear? So this is already there in your mechanism. So two mechanisms are there in this particular chapter. Dehydration of alcohols to alkenes, hydration of alkenes to alcohols. Okay, both the mechanisms are very, very important. Please prepare it thoroughly. Next part of the question, involved enzyme involved in the fermentation of glucose, that is your zymase. Okay, so and the reaction, you can see this reaction. So glucose in presence of zymase gives you ethanol plus CO2. Okay. Yes, very good, Rosen. Okay, now let's see what was the question that was asked in PU2 2025 paper. Okay, Lucas reagent is an important reagent which helps to distinguish between three cases of alcohol. Write the chemical composition of Lucas reagent and explain how the above reagent helps to distinguish between primary and tertiary alcohols only. Okay, so Lucas reagent, what is the chemical composition? That is 1 mark. We have already discussed anhydrous HCl and HCl and anhydrous ZnCl2. And primary, there will be no turbidity. Tertiary, there will be turbidity immediately. Okay. Next, illustrate the preparation of ether by Williamson ether synthesis with a general chemical equation. So, you can see here the first part I will not discuss because we have already discussed this answer. In Williamson ether synthesis, what happens? Alkyl halides reacts with sodium alkoxide to form ethers, right? So, Rx plus R dash ONA give you ROR plus NaX. Okay. Okay, Rahish, which question do you want me to repeat? Okay, so first question, if you want, I'll explain once again. I have already explained this in the previous question. Okay, so we have anhydrous ZnCl2. Okay, what is Lucas reagent? Lucas reagent is anhydrous ZnCl2 plus HCl. Okay, now I'll just tell you what happens. Let's see. When you have ROH and you react with this one anhydrous ZnCl2 plus HCl, okay, you get RCl. Now this ROH can be primary, secondary or tertiary, right? Now this RCl, when it is formed in the solution, it will create some turbidity. Turbidity means the solution will become slightly dense and it will not be visible clearly. So now what happens? If it is a tertiary alcohol, the turbidity will be produced immediately. Okay. If it is a secondary alcohol, turbidity will be produced after 5 minutes. If this alcohol is a primary, then there is no reaction or no turbidity is formed. Okay. In that way, you can differentiate. Okay. Rahish, I hope this is clear to you. Okay. Now let's, 1 second. Okay. Now let's go to the next question. Explain the mechanism of hydration of alkene to alcohol. So this was in midterm 2024 paper. So already we have discussed hydration mechanism. Explain the preparation of picric acid from phenol. So this is a good question. So this mechanism already I have discussed the same thing. But picric acid, how will you get? If you take phenol and react with concentrated nitric acid, all the ortho and para positions will be substituted and you will get something called as 2,4,6-dinitrophenol, or it is picric acid. Okay. Next, explain Riemer-Tiemann reaction with an example. Already we have discussed. Compound A is treated with sodium ethoxide in presence. So first of all, Riemer-Tiemann reaction I have already explained. You can just write, understand. We have already discussed this question. Let's talk about this question. Compound A is reacted with sodium ethoxide in presence of dry ether to give compound B and sodium bromide. Identify A and B and the name of the reaction. Okay. So you are getting sodium ethoxide, right? So see here, you have a compound A, okay, it reacts with sodium ethoxide, okay, it reacts with sodium ethoxides in presence of dry ether to give a compound B, okay, and sodium bromide, okay. Then identify A and B and the name of the reaction. Now this can be anything you can write here, any halide or any haloalkane you can write. So if I write here CH3, but since here Br is produced, this has to be Br. Okay. Now once the reaction has taken place, I'll get a ether here, that is CH3OCH2CH3. Okay, that is there. So now we will get this one, and what is the name of this reaction? This is Williamson ether synthesis reaction. Clear? Okay. Yes. So just a minute. Okay. So now we are done with organic chemistry. So next let's move to inorganic chemistry quickly, and then we'll start with physical chemistry. Okay. So yes, let's start with the next chapter from, that is your coordination compounds chapter. Okay. let's start that one. Yes, so those are waiting for inorganic chemistry. Okay, Royson, we have aldehydes. We have only taken haloalkanes and haloarenes because that was what poll we have conducted. Maximum students have only alcohols and phenols and ethers. Okay, aldehydes, if you have that in your what I'll say syllabus, then don't worry, I'll make another video for aldehydes, ketones and carboxylic acid. Okay, in this video we don't have. Okay, Rahish ma'am, how to become e-chemistry teacher? Online you are asking? Okay, Rahish, for becoming a chemistry teacher, you have to complete your like depends on like your like bachelor's and master's should be in chemistry, and after that you need to do another teaching degree like B.Ed and all. If you want to teach in schools, if you want to teach in coaching centers and all, then this is not required. Okay, yes. Okay, now let's move to coordination compounds quickly. So what is the weightage of this chapter? You will get 11 questions, 11 marks, 3 theory questions and 2 MCQ question. Now I want all of you to answer quickly all the MCQ questions. Let's see what type of bond is LMN in the complex compounds. Is it ionic, metallic, coordinate or covalent? From the name of the chapter only all of you should be able to answer. Hi Chatur, good afternoon. Okay, Rasan, don't worry, I'll make another video where we will be discussing about this aldehydes, ketones and this one. Okay, and yeah, coordinate bond is there. From the name of the chapter we all can guess. Very good. Next, if the secondary valency of COCl3.4NH3 is 6, the secondary valency is 6 here. The solution conductivity in silver nitrate corresponds to dash electrolyte. So how will you know which type of electrolyte it is? If there is one, and if in that electrolyte, if it is giving you 1 cation and 2 anion, then it is 1:2. If 2 cation, 1 anion, then it is 2:1. So like that the name of the electrolyte is given. Okay. Try this question. Students, those who are answering, please put question number and then you answer. Okay. Yes, please put question number and then answer so that I can know which one you are actually answering. Okay, let's see here. So we have secondary valency COCl3.4NH3, right? So I can write 6 coordination. Secondary valency is 6, that means there has to be 6 ligands here inside. So I'll have 4 NH2 and 2 Cl2. That means there is 1 Cl outside. So if I dissolve it in water, I'll get 1 cation and 1 anion, right? So 1 cation and 1 anion means this is a 1:1 type isomer. So it is option number A. No dear, 2 is 1:1. See, you have to, coordination number is 6, means with cobalt there will be 6 ligands, right? So there will be a square bracket and then you will have 1 chlorine extra which has to be outside present. So that is why now when it dissolves in water, you'll get one whole, this complex as 1 cation and this chlorine as 1 anion. So I'll get 1 cation and 1 anion, so it is 1:1 type. Okay. Next, question number 3. Given that 1 mole of NiCl2.6H2O with excess of AgNO3 precipitates 2 moles of AgCl, what is the secondary valency of nickel? Again a similar question. You have 1 mole of NiCl2.6H2O with excess of AgNO3. It precipitates 2 moles of AgCl, means 2 chlorine will be outside. So what will be the formula of the compound? You will have NiH2O whole 6. Now since 2 moles of chlorine is outside, 2 moles of AgCl is formed, 2 chlorine has to be outside. Okay. Now what is the coordination number of nickel here? 6. So that means I will get secondary valency as 6 here. Okay. Next question. What is the sum of the oxidation number of cobalt in this? Oxidation number of cobalt in both of this. So if I find the first one, you have CO, H2O, and then you have Cn, and then you have En whole 2, okay, and that will give me 2 plus. Okay, so what will be there? This is X, Cn is -1 and that gives me +2, so X will be +3 here. Okay, cobalt is in +3 state. Next you have COBr2En2 whole plus, so you have COEN, okay, whole 2 Br2 and then plus here. So I'll get x minus 2 is equal to plus 1, again I'll x is equal to 3. So if I add these two, the sum will be 6. That is option number D. Yes. Okay. Next, what is the primary valency of iron in the coordination entity of the given compound? Primary valency means you have to calculate the oxidation number here. So the compound given is like this: Fe4 Fe CN6 3. Right? Now see, how would this compound would have generated? This would be plus 3 and you would have Fe CN6 4 minus, right? Now when they would have crisscrossed, you would have got this compound. So what is the valency of this particular compound? 4 minus. So if I want to calculate the oxidation state of Fe, this is x, then I have minus 6, I have minus 4, x will give me plus 2 here, right? So that is why option number B here. How plus 3? Which one, dear? I think you are asking about the previous question. So if plus 3, you can see cobalt, let it be x, water is a neutral ligand, so 0, Cn is minus 1, En is neutral ligand, so 0, and then plus 2 is there. So I'll get plus 3 here. Next, cobalt is x, En is neutral ligand, so 0, Br2 is minus, each Br is minus, so it is minus 2, and here this is plus, right? This is plus. So I have plus 1 on the right hand side. So if this 2 goes here, I'll get 3. So the sum of the oxidation number of cobalt in both will be plus 3 plus plus 3, that is plus 6 here. Okay. Okay, next question Fe you are asking. Okay. Okay. So that is what I told you. See, how would have this compound, see this compound would have been generated when you would have done the crisscross of each of their valencies. This compound 4 would have come from here and this 3 would have come from here, right? That is why when you do crisscross, this 4 comes here, this 3 comes here, and we get this final product. So that is why here Fe is in plus 3 state. And now if I want to just calculate for this particular ion, this is x, this is minus 6, and this is 4 minus, and I'll get plus 2 here. Okay, Chatur, I hope you got it. Okay. Now moving to the next question. This is sample question paper 1 of 2025, 1 marker question. Try to answer this question now. The complex PtCl2.4NH3Br2 is treated with excess of AgNO3 solution. 2 moles of AgBr is precipitated. The primary and the secondary valency of this complex is 2 moles of AgBr is precipitated. That means 2 moles of bromine will be outside here. So just a minute. Okay. So if I want to write the formula, it is Pt. Okay, then I'll have NH3 okay, bromine 2 will be outside, 2 Cl2 will be inside, and I have like this the compound. This is the formula of the compound, right? Now the question is asking you first the primary valency. Primary valency means the oxidation state of platinum. Let this be X, okay. NH3 is a neutral ligand, so 0. Chlorine is minus 1, so minus 2. And here bromine is minus 2 is equal to 0. So X I will get plus 4, right? So I have which option? There's only one option with like that where I have primary valency of 4. And then if you see the total number of ligands is 6, so that is why it is 4 and 6. The primary and the secondary valency of the complex is 4 and 6 respectively. Okay? Good. Let's ambidentate ligand is. This one all of you can answer. Just put question number 7 and answer me. What is ambidentate ligand? Yes, Royson, very good. Cn minus is correct. Ambidentate ligand. Now here don't get confused. NO2 plus is given. If NO2 only is given, that is also an ambidentate ligand, but not NO2 plus. Okay. Yes. Let's moving to question, sample question paper 2 of 2025. There was 1 marker question. Square planar complex of the type MABXL shows what type of isomerism? 2 cis and 1 trans, 2 cis, 2 trans, 1 cis and 2 trans, and 1 cis and 1 trans. Now see here, when you have this MABXL type, okay, you have to fix one position A. Okay. Now with respect to that, you have to keep B in the opposite side. Okay. You can then keep M, A and X on the opposite side. Then you have one more possibility where you have L on the opposite side. Okay, so these are the three types of isomers you will get. Now it is told that out of these three, 2 we will get as cis and 1 you will get trans. Means if you are considering A and B, okay, A and B are the two opposite sides. So in one isomer A and B are opposite. In the other two isomers you find AB are in the same side. Okay, so that is why you will get 2 cis and 1 trans. That is option number A here. Okay. Next question, the magnitude of CFSE can be related to the configuration of d orbitals in a coordination entity is. Okay, so the D4 configuration we are talking about. Okay, so D4 configuration, just a minute. Yeah, okay. So now if I'm talking about D4 configuration, okay, what will be the configuration under, if I am telling strong field ligand, okay. In case of strong field ligand, what happens? There is higher splitting, more splitting, pairing takes place. So I'll say that delta O is higher than pairing energy. In that case, the configuration is T2G4. Now, if it is a weak field ligand, what happens? In case of weak field ligand, what happens? There is suppose two orbitals are there, T2G and EG. There is 3 T2G will be filled and the 4th orbital will go to the higher level, right? It is like this. If T2G is there, EG is there. If it is a weak field ligand, what will happen? 1, 2, 3 and 4. D4 configuration is like this. In that case, what happens? This delta O is very small. Delta O is less than P. So we will get here T2G3 and EG1. Okay, so these are the two conditions you should be knowing now. Now let me just tell you what is the correct option that we are having here. If delta O is less than P, means this condition, then do we have this configuration T2G3EG1? Yes, that is correct. Next, if delta O is greater than P, this one, then we will have this configuration. No, we will have T2G4 configuration. T2G-EG2 we won't get in any condition. And here next one, T2G4EG0 we will get if we have delta O greater than P. So that is also wrong. Okay, option A is the correct answer here. Next, in sample question paper 3, this was the question. The transition metal present in the red pigment of blood hemoglobin is. So we all know that iron is present in hemoglobin. So option number C here. Next, the geometric complex of FeCO5. So if you know the structure of FeCO5, it is like this. Okay, so it is a shape of trigonal bipyramidal, and the correct option is option number C here. Okay, yes Chatur, you are absolutely correct. Now let's move forward to 3-marker question. So sample question paper 1 of 2025, the 3-marker question is, for the complex mercury tetrathiacyanato S cobaltate, what is the coordination number of cobalt? Identify the ligand present in the complex, and does ionization isomerism exist for this complex? Yes. Okay, now please try to answer this question. You have been given with mercury, so let us first write down the complex formula. Okay, sorry. Okay, what is the first formula of this one? Mercury is there. Okay, then you have tetrathiacyanato S. So I have cobalt with tetrathiacyanato S. Okay, mercury tetrathiacyanato S cobaltate. Okay, so now if you see here, what is the coordination number of cobalt? This is a monodentate ligand, it forms only one bond, so the 4 bonds are formed here with cobalt. So what will be its coordination number? 4. What is the ligand present here? SCN minus. Ionization isomerism, it is possible? No. In ionization isomerism, what happens? If you have two things which can behave as a ligand. For example, if I have like this something, CO, SCN4 and Br is present. Now Br can also act as a ligand, SCN can also act as a ligand, they can exchange. That is called ionization isomerism. But here this is a metal, it is not a ligand, so these two cannot exchange, so there is no ionization isomerism here. Okay, now moving to the next question. Crystal field splitting. sketch the energy for tetrahedral complex. So what is crystal field splitting says us? So crystal field splitting says that when all the d orbitals are degenerate or having the same energy, and when ligands approach them, okay, there is repulsion due to which the d orbital split. The difference between these d orbitals is called as crystal field energy. That you have to mention here. Next, the sketch for tetrahedral complex, you can take it from the diagram. Please make sure that you do proper leveling of these diagrams. Okay. Next, students, if you are liking the session, please share with your friend. Okay, I am doing now 3rd chapter, and we will be doing all the 6 chapters today. So don't worry, just revise with me, and if you can, just put down your comments, interact, make it more interactive so that we can enjoy, and please share with your friends so that we can have a group study here. Okay. Next question, what is the significance of synergic effect in metal carbonyls, and how many bridged and non-bridged carbonyl ligands are present in this particular complex? So what is the role of synergic effect? It strengthens the metal to carbon bond. Okay, metal to carbonyl ligand bond is strengthened because of synergic effect. There is a sigma bond, there is a pi bond, and that is why the bond is very, very strong, right? Next, how many bridged and non-bridged carbonyl ligands we have? In octacarbonyl dicobalt. So if you know this structure, it is like this. One second. Yeah, we have structure like this here. Okay, so this is the structure. So we have 2 bridged carbonyls and 6 unbridged carbonyls. Okay, so what will be my answer here? First of all, synergic effect strengthens the bond between metal and CO, and bridged and non-bridged, if you see, you have 2 bridged and 6 non-bridged. Okay, yes, very good, Royson. Next, we'll have write the IUPAC name of this compound, draw the geometrical isomers for this complex. So IUPAC name you can easily write down. What is the IUPAC name of this one? First we will write the name of the ligand, alphabetical order, right? So it is bis ethane 1,2-diamine, first one, because the name is starting from E. Oh sorry, first we have to write this one, sorry, this one should be written first. Okay, so it is like this. I'll correct it. So we have dichlorido, first will be dichlorido, okay, then you have bis ethane 1,2-diamine, okay, and then you have to then write the name of the metal, that is cobalt. And the oxidation state, if you check, this is X, chlorine is -2, and this side I have +1, that gives you +3. Okay, so that is the name of the compound. Geometrical isomers, so if you see, we have cis and trans. If you keep chlorines on the opposite side, that is the trans isomer, this is the trans isomer, and you have chlorine on the same side, this is the cis isomer. Okay, clear? How bis? Yes. So students, when we have on the name, if there is any number 1,2-diamine, in the name itself, if we have any number, then instead of di we should use bis. Okay, similarly instead of 3 we have to use tris. Okay, so that is what you should be. How chlorine is -2? Because there 2 chlorines are there, right? Each chlorine is -1, 2 chlorines means -2. Chatur, are you getting this one? You have cobalt is X, 1 chlorine -1, 2 chlorine -2. Okay, then En is neutral, and outside ligand charge is +1. So I will get +3 here. Okay, I hope you have got it. Okay, next, write any limitations of valence bond theory. So 3 limitations have been asked. I have given you 6. You can write any 3. It has a number of assumptions, does not give quantitative interpretation of magnetic data, color, no data it gives, then thermodynamic and kinetic stabilities. These 4 points, any 3 you can remember. Okay. Next, we'll move to sample question paper 3 questions. Use the abbreviations of the following ligands and identify the number of donor sites and write the formula of. So each ligand. En formula is what? En formula is like this: CH2N C double bond O minus, then you have CH2, then you have N C double bond O minus. Okay, so you have 1, 2, 3. So these 2 oxygens are donor site, this nitrogen is a donor site, this oxygen. So total 6 donor sites we have. Okay, Then we have second one. Okay, this is option, this is B, EDTA. This is for EDTA. Next, A is what? EN. EN is CH2, CH2. Then you have NH2 and NH2, right? So that will be total, we have 2 donor sites, okay, 2 donor sites, and the formula is like this. Then we have C, which is PPH3, okay? So you have phosphorus, then you have pH, pH and pH, okay? So this is the ligand present here. Clear? Yes, very good. Now moving to the next question, sample question paper 3 of 2025. Using the valence bond theory, explain the geometry, hybridization and magnetic property of COF6 3-. Now students, one question of this type will definitely be asked in the exam, and there's a proper way of answering that question. So I'll tell you the way right now. Please note down this answer with me. Okay. So first of all, whenever such question is asked, you have to write the oxidation state of cobalt here. Okay. So just you have to write like this. The oxidation state of cobalt in COF6 3- is +3, right? So what is the electronic configuration of cobalt +3? It is 3d6, right? Because cobalt is 3d7 4s2. Now 3 electrons are lost, so 3d6 we will get, and you have to draw that 3d6. So 1, 2, 3, 4, 5, and then you have 6th electron here. Now what is the ligand that is given to us? Fluorine, right? So fluorine is a weak field ligand. Okay, so what will happen? No pairing of electron takes place. No pairing of electron takes place. Okay. So that means what? If no pairing of electron takes place, we need the outside orbitals. So I have 3d orbitals. We have 4s, 4p and 4d. So what will happen here? We have 3d. These are 6 orbitals present. Then you have 4s orbitals present. You have 4p orbitals present. And you have 4d orbitals present. Now what will happen? There are 6 ligands, right? So these 6 orbitals, that is 1s, 3p and 2d, will undergo hybridization. So total how many orbitals are undergoing? 1, 2, 3, 4, 5 and 6 to form 6 new hybrid orbitals. So what will happen now? You have to write like this. 6 new, oh sorry, you can just write down 6 sp3d2 hybrid orbitals. Okay, so what will happen in this hybrid orbitals? Fluorine will come and donate the electrons, right? So you can just write like this. Okay, so these are the electrons donated from fluorine. So that is why we are using a cross symbol here. Okay, this is to denote, so 3d6 here we have the to denote the electrons of the metal. This is the electrons from the ligand. So now what are the questions asked here? Geometry. Explain the geometry. So whenever you have coordination number 6, the geometry is always octahedral. Next, what is the hybridization? Hybridization is sp3d and 2. Next, what is the magnetic property? So can I find any unpaired electron in the metals? Yes, in the metal there are 4 unpaired electron. So if we have unpaired electron, then it will be a paramagnetic substance. Okay, clear? Yes, very good, Royson. It shows that you have revised the chapter well. Next question is, give any 3 applications of coordination compound, sample question paper 3 of 2025. Anything, any 3 out of this you can write. Okay, I have given some of the examples. Next, PU2 2025 exact question, the postulates of Werner's theory. That is one of the most important question. The first postulate you have to write that it has 2 types of valencies, primary valency and secondary valency. The second point you have to write about primary valency, which is it is non-ionizable, and it is primary valencies, they are normally ionizable and are satisfied by negative ions. The secondary valency you have to write they are non-ionizable and satisfied by negative and neutral ions. And then that is all 3 points you have to write about the Werner's theory. Okay. Next we have Question from here. CONH3-5Br-SO4 is an octahedral complex. Write its IUPAC name and draw the diagram which indicates the splitting of d orbitals in the above complex with respect to CFT. Now if you see, there are 6 ligands, so there is an octahedral splitting. And what is the name of this compound? So name of the compound you can easily write. So first of all of you can comment and tell me the fine, Royson, there is no problem. You can just revise. We are just going to finish this chapter, and those students who are having this, they can just revise. Okay, just few minutes you can wait, Royson. So can you just name this compound first of all, the IUPAC nomenclature? All of you, anyone can try the IUPAC nomenclature of this chapter, of this question. IUPAC nomenclature. What will be the IUPAC nomenclature? First I have amine group, right? Amine group, then bromine. So I will have penta-amine. Okay, then I have bromo or bromido, you can write. Next you have cobalt. What is the oxidation state of cobalt here? Let it be X. Ammonia is 0, -1, -2 equal to 0. Sulfate is -2, bromine is -1. So the net charge will be +3. So cobalt 3 I can write like this, and then sulfate. Right. So now if you see here, this is the first part of the question. Next, when you draw the diagram, for crystal field splitting in octahedral complex, T2G will come here, EG will come here. Okay, Royson, you have not, yeah, penta-amine, bromido, cobalt, yes, that is correct. Yes, the charge will be 3. Okay, next question is also from PU2 2025 paper. Write the facial and meridional isomeric structure of this particular compound. Mention the coordination number of the metal ion in the above complex. So you can see that there are, so when you do facial and meridional isomers, that will give you 2 marks, and the number of coordination number for this one, that will give you 6. The total number of coordination or ligands here is 6, so that is why coordination number will be 6. That gives you 1 mark. So total 3 mark question. So facial and meridional, you can see from the book, it is given like this, and the second part answer is 6 here. Moving to the next. Okay, so we are done with the haloalkanes and haloarenes chapter. Sorry, we are done with already. Now we have also completed coordination. Let's quickly move to the D and F block chapter. Okay, yes, many of you are waiting for D and F block chapter. Very, very interesting and important chapter. Total weightage of this chapter in the final board exams is 10 marks. Okay, let's move to the first question, 1 marker question. The magnetic moment of a transition metal is √15. Therefore, the number of unpaired electrons present in it. Now, when it is √15, how do we get the magnetic moment? It has to be n into n plus 2. So now you think, what can be the value of n so that I'll get √15? Let me have some water, and you can also take some water and then answer this question. Yeah, so yes, if I have 3, that will give me 15, so option number A here. Next question, potassium permanganate acts as an oxidant in the alkaline and acidic medium. The final products formed from in the 2 conditions are respectively. So when potassium permanganate oxidizes others, itself it will get reduced. So what is the reduced product formed in the acidic medium and in the alkaline medium? So in alkaline medium we get MnO2, and in acidic medium we get Mn2+. Okay, so that is why option number D here. No dear, 2 is D. Next question, number of electrons in the 3d orbital of this one is given. Unpaired electrons 3, 3, 5 and 4 respectively. Which of the following will have the largest magnetic moment? Just now we have discussed the magnetic moment will depend on the number of unpaired electrons. So you can see in Mn2+ there is highest number of unpaired electrons, that is 5. So it will have the highest magnetic movement or moment, that is Mn2+. Next question, the correct order of E0 values are given for successive elements. So you know that the E naught value is highly positive for manganese. Okay, if you have Mn 2 plus to Mn, okay, this value is Mn2 plus is having D5 configuration. It is highly stable, so it doesn't want to get reduced easily here. So that is why the value is very less or highly negative, I can say. So the first element has to be manganese, and there's only one option like that. So that is why option number A here. Okay. Next we have question number 4, the correct order of ionic radius of the given compounds. So if you can just see the periodic table here, yttrium is in 5th group, and in the 6th group we have these all other elements. So down the group what will happen? The size will increase. So the lowest size will be Y3 plus. Okay, I have two options like that. So I can eliminate that. Then this 3 elements, that is lanthanum, europium and lutetium, they belong to one period. And along the period the size decreases. So the lowest one after yttrium will be lutetium, then europium and then lanthanum. So option number D. Okay. Yes. Very good. Now let's move to 2 and 3 marker questions. So the first question is from sample question paper 1 of 2025. This is a very good question, means a very unexpected question. So you do need to do this question. Iron catalyzes the reaction between iodide and persulfate ions in the reaction. This is the reaction given. Explain the catalytic action of the catalyst iron by using the chemical reaction. So you need to know this you might not have studied, so please, it is there in the book. Fe3 plus first converts I minus to I2 and Fe2 plus, and this Fe2 plus then react with S2OA to give you Fe3 plus. So that is how it works as a catalytic activity. Okay, this is important question. Please take a screenshot here. Next, study of actinoids is very difficult. Give 3 reasons. This is repeated many times. So these are 3 reasons here. They are radioactive, they have very short half-life period, and they are produced in nanograms. So that is why it is very difficult to study them. Next we have a question here. A student of 2nd PU, like you people, performs 2 trail of experiment between Ki and KMnO4. Okay, the student does 2 experiment between Ki and KMnO4. In the first trail, student adds small amount of acid to the reaction mixture, and in second trail, student forgot to add the acid to the reaction mixture. The student observed that different color was obtained in the first and second trail. Give the reason for the above observation and write the possible chemical reactions for both the trail. So just now we have discussed KMnO4. If you are adding acid, it gets converted to Mn2 plus. But if there is no acidic medium, KMnO4 gets converted to MnO2. Okay, so that is the reason of the difference here. And let's see here. So in acidic medium, Mn2 plus is formed, which is a colorless, and only iodine color is visible. In neutral and alkaline medium, what happens? Brown color MnO2 precipitate is formed, giving a different color compared to the first case. So reaction in first case, what happens? MnO4 I minus gets converted to I2, MnO4 minus gets converted to Mn2 plus. In the second case, MnO4 minus gets converted to MnO2, which is a brown one, and I minus gets converted to, okay, here this is a small error, IO2 gets converted to, one second, iodate ion. Okay, here's the change, that is converted to iodate ion. Okay, next question is, when a chromite ore A is fused with sodium carbonate. So this question has been also asked in a different way. This is just the preparation of what? Preparation of, you can see, chromite ore. It is used for the preparation of K2Cr2O7, right? So the preparation of K2Cr2O7 is a very, very important question. All the 3 steps you should remember with the balancing of the reaction. So this is but asked in a different way. So first iron chromite is taken, it is get converted to sodium chromate, sodium chromate to potassium chromate, sodium chromate to sodium dichromate, sodium dichromate to potassium dichromate. Okay, yes, Roshan, you are absolutely correct here. Next, fluorine has the ability to stabilize the most of the transition metals in the higher oxidation state. Give 2 reasons with an example. So fluorine stabilizes the higher oxidation because of higher bond enthalpy and higher lattice enthalpy. For lattice enthalpy, example is COF3, and for bond enthalpy we have VF5 and CRF6. Okay. Next, what is lanthanide contraction? Name two elements of actinoids which exhibits +7 oxidation state. So this is sample question paper 2 question. Lanthanide contraction, the steady decrease in the size of the elements due to the poor shielding effect of 4f electrons is called as lanthanide contraction. Now what are elements of +7 oxidation state? Np and Pu. Okay. Next we have name an important alloy which contains maximum percentage of lanthanoid metals and mention one of its use. So this was a 2-marker question. So this is, we all know, it is mic metal, and what is this used? It is used in magnesium based alloys to produce bullets and other thing. Next, write the equations for the preparation of KMnO4 from pyrolusite ore. What is the color of KMnO4 crystals? So again, this is also preparation of KMnO4. You must remember this equation. This is your pyrolusite ore. MnO2 is converted to K2MnO4. Then MnO2 is again then converted to MnO4 minus. Okay. And the color of this one is purple. Clear? Yes, very good. Next we have transition elements have higher enthalpies of atomization. Give 2 reasons. Among 3D and 4D series of transition elements, which series has higher enthalpy of atomization? So first of all, transition elements have unpaired electrons. Now these unpaired electrons are involved in metallic bonding. That is why they have higher enthalpy of atomization. So that is 2 reasons. First reason is they have unpaired electron. Second reason is these unpaired electrons are involved in metallic bonding. Okay. Next, among 3D and 4D, which one will have higher enthalpy of atomization? As the mass increases, what happens? The bonding increases. Okay, so that is why here we have 4D will have higher enthalpy of atomization. Okay, so let's move to the next question, 2025 PYQ. Write any 2 characteristic properties of interstitial compounds. Very simple question. You know they have high melting point, they are chemically inert, and they retain the metallic conductivity. These are some 3 points of interstitial compounds that you should remember. Next, write the balanced chemical equations in the manufacture of K2Cr2O7. I have told you this question is super important. Every year this question is asked. So please remember the reactions properly. Once again, I have given you iron chromate to sodium chromate, sodium chromate to sodium dichromate, sodium dichromate to potassium dichromate. Okay. Next, what is lanthanide contraction? Write 1 comparison and 1 difference between lanthanoids and actinoids with respect to oxidation state shown by them. Okay, so you have to write 1 common thing between lanthanoids and actinoids regarding their oxidation state and 1 difference between them. So first of all, what is lanthanide contraction? We all have discussed. Now what is similarity? They both have a common oxidation state of +3. That is the similarity. Now what is the difference between them? Lanthanoids mostly exhibit limited oxidation state of +2, +3, +4, with +3 being the most stable. But actinoids can show much more oxidation states, like they can show from +3 to almost +7. And we have also discussed 2 elements which shows +7, Np and Pu, right? Yes. Fine. Next, we'll discuss some other important questions that I find is important. So what are the amphoteric oxides? You have 2 amphoteric oxides, V2O5 and CrO3. This can be easily asked in MCQs. It was asked, I think this question was there in final boards or 2024 final board exam paper. This was there in MCQ question. So please remember the amphoteric oxides. Next, this is very good question. Why is Cr2 plus reducing and Mn3 plus oxidizing when both have D4 configuration? Now I want to explain this answer. If you are understood, just give me a thumbs up after I explain. Okay, so please remember what I'm saying. Please understand. You don't have to remember this answer. If your concept is clear, easily you can answer this question. So let's see. Cr2 plus, okay, its configuration is, if you know, chromium electronic configuration is 3d5 4s1, so it will have D4 configuration. Okay, and here we have Mn3 plus. Mn3 plus is also having D4 configuration. That is already given in the question. They both have D4 configuration. Now Cr2 plus, if it goes to Cr3 plus, okay, that is D3 configuration. Now this D3 configuration is very stable. Why? Now since you have already studied coordination compounds, you know that if I have D3 configuration, its electronic configuration will be T2G3. This T2G3 configuration is very, very stable. Okay, so Cr2 plus from D4 it wants to goes to D3. It gets converted from Cr2 plus to Cr3 plus. Why? Because Cr3 plus configuration is highly stable here. Now since it is undergoing oxidation, Cr2 plus is undergoing oxidation, it will behave as an reducing agent here. Okay, now let's talk about Mn3 plus. Mn3 plus will get converted to Mn2 plus because it will get D5 configuration, which is again very stable because of half-filled configuration. Oh, just a minute. 1 second. 1 second, my dear children. Okay. Okay, fine. So what I was talking about here was okay. So yeah, what I was saying here was Mn2 plus will have D5 configuration. So Mn plus 3 to plus 2 is what? Reduction. So here it, since this one is undergoing reduction, it will behave as an oxidizing agent. Okay, so both have D4 configuration, but to gain stability, chromium goes to D3 whereas manganese goes to D5. Chromium undergoes oxidation whereas manganese undergo reduction. So chromium undergoing oxidation will behave as a reducing agent, manganese undergoing reduction will behave as an oxidizing agent. So that is why chromium 2 plus is reducing whereas manganese 3 plus is oxidizing. Okay, yes. If this question is clear, please put a thumbs up. If not, I'll explain once again. If this question is clear to everyone, please put a thumbs up. 10 students are here. I want all of you to respond here if this question is clear to all of you. Okay, Prajwal is saying once more. Okay, so please understand, Prajwal, chromium is having Cr2 plus, they are saying, right? That is D4 configuration. Now chromium plus 2 gets converted to chromium plus 3. Okay, why? Because this is D4 configuration, this is not stable. D3 configuration is stable here. Okay, why? Because it is having coordination compounds. If you have studied the d orbital split, right, T2G3 configuration we will get, which is highly stable. And since it is undergoing what, from plus 2 to plus 3 oxidation, so chromium 2 plus will behave as a reducing agent. Okay, this part is clear. Now let's talk about Mn2 plus. Mn2 plus is having D4 configuration. Okay, now Mn plus 3 is having D4 configuration. It goes to Mn2 plus, which is having D5 configuration, which is again very stable because of half-filled configuration, right? So here what happens, Mn plus 3 undergoes reduction to gain stability, chromium 2 plus undergoes oxidation to gain stability. Since chromium 2 plus is undergoing oxidation, it will behave as a reducing agent, and Mn plus 3 is undergoing reduction, it will behave as an oxidizing agent. Okay, so I'll show you how can you write this answer. Okay, fine. You can just see here, Cr2 plus electronic configuration is 3d4. It readily gets oxidized to Cr3 plus, which is a stable half-filled T2G configuration. Therefore, it acts as a reducing agent. Mn plus 3 electronic configuration is 3d4. It gets converted to Mn2 plus, which has a stable D5 configuration. So both Cr2 plus and Mn3 plus are D4, but Cr2 plus prefers to lose one electron, whereas Mn2 plus prefers to gain one electron. Okay. Yes, now let's move to the next question. Which is a stronger reducing agent, Cr2 plus or Fe2 plus? Which is a stronger reducing agent and why? Again the question comes here. Now see, let's explain this one also. I want to explain you very clearly. Cr2 plus and Fe2 plus. Students, I want none of you to remember these answers. You just need to understand the concept here. Now they are saying that both, which is a stronger reducing agent, means both are behaving as a reducing agent. You just need to say which is a stronger reducing agent here. Now Cr2 plus will get converted to what? Reducing agent means what? It will reduce others, itself it will get oxidized. So Cr2 plus will get converted to Cr3 plus. Fe2 plus will get converted to Fe3 plus. Now this is D3 configuration, T2G3 configuration. This is D5 configuration. Now this is half filled configuration and this is T2G3 configuration. So you should remember that T2G3 energy, you know, d orbital split. So T2G3 energy is lower than d orbitals, right? So that is why this is having less energy, or sorry, 1 second. Yeah, so this is having less. Okay, so this is having less energy, or it is more stable. Okay, so then which is a stronger reducing agent here? Cr2 plus is a stronger reducing agent. Yes. Okay, you can write like this. So just let me show you how you can write the answer. So Cr2 plus tends to get oxidized to Cr3 plus. Now Cr3 plus has a stable T2G3 half filled configuration. So therefore Cr2 plus is eager to lose one electron, and Fe2 plus gets converted to Fe3 plus, which is having D5 configuration. But the process here is less favorable as compared to Cr2 plus to Cr3 plus, since Cr3 plus is more stable than Fe3 plus. Okay. Okay. Next we'll go to question here. Magnetic moment of Ti3 plus. So all of you know how to calculate the magnetic moment, root over of n into n plus 2, right? Scandium, titanium. Titanium electronic configuration is 3d2 4s2. Okay, sorry. Titanium 3 plus will have 1 electron here. So 1 into 1 plus 2, that is root over of 3, which is 1.732. Okay. Yes, absolutely correct, Rasan. So yes, we are done with now the chapter D and F block. Now let's quickly move to our physical chemistry. So those students who are waiting for physical chemistry will now be very happy. But first let's do the chapter electrochemistry, and then we'll move to last chapter, that is solutions. Okay, so electrochemistry, we have 13 marks where you will get 2 questions in numerical, 2 questions in theory, and 1 question in the MCQ in the final board exams. Okay, so let's see the first MCQ. Okay, before that I just want you to go through this. You can just take a screenshot, all the terms I have mentioned here, what is resistivity, resistance, and their symbols are mentioned here. And there is one more formula sheet that I have given you, so you can just revise all the formulas quickly before starting. Okay, so all of you please take a screenshot of this, and you can just make a formula sheet for all the things that is present here. Okay, so next we'll go to 1 marker question. The question here is the EMF of hydrogen electrode in terms of pH is. Very good question. So see, if you have H plus, it will gain 1 electron to give you half H2, right? That is the reaction. Now if I want to write the E of the cell, E of the cell will be equal to E naught of the cell minus 0.059 by n log of pressure of H2. Pressure of H2 is considered as 1 atm divided by H plus concentration, right? Now what we know, that pH is equal to minus log of H plus, right? Then what will be the H plus concentration? That is equal to 10 to the power of minus pH. So in place of this H plus, I can consider this value. So I can write E naught value is 0 here, minus 0.059 by n log of, this is 10 to the power of minus pH. Okay, see, H plus concentration is 10 to the power of minus pH. Now when it goes up, it will become 10 to the power of plus pH. I hope you are getting. At denominator it will be minus pH. When it goes to numerator, I can write it like this. So I can just take this pH to this side. I'll get minus 0.059 pH log of 10. Log 10 value is 1, right? So what I'll get, minus 0.059 pH. That is option number D here. Yes, Royson, you are absolutely correct. I want other students also to answer here. I can find only one student answering. Next we have the E naught values here. Mg plus 2 to Mg is given. Okay, Mg plus 2 to Mg is there. Then you have Zn2 plus to Zn. Okay, next we have Fe2 plus to Fe. Okay, so all these values are given to me. What is magnesium reduction potential? Minus 2.37. Zn is minus 0.76 and is minus 0.44. Okay, these are all reduction potential. So if you see, the reduction potential is the least, or I can say the reduction potential is highest for this one, right? Fe2 plus reduction potential is highest and Mg2 plus reduction potential is least. That means Mg will actually undergo oxidation, okay, better. So the question here is asking which of the following is correct. Zn will reduce Fe2 plus. Now if you see Zn and Fe, Zn reduction potential and Fe reduction potential. Fe reduction potential is more, so Fe will undergo reduction, right? Fe will undergo oxidation, Fe will undergo reduction if I have zinc and Fe in one place, okay? Zn2 plus is present and Fe2 plus is present. Now I can see that the reduction potential of Fe2 plus is more from this value. So that means Fe will undergo reduction. If in the same component there is a redox reaction has to happen, Fe will undergo reduction, then Zn will undergo oxidation, right? If Fe is undergoing reduction, it will behave as an oxidizing agent and it will oxidize Zn, and Zn is undergoing oxidation, so Zn will behave as a reducing agent and it will reduce Fe. So that is why the first statement given is correct, that is Zn will reduce Fe. Yes, again Royson is correct here. If you have any student any problem in this question, do let me know, or else I'll move to the next question. Next here, the standard reduction potentials for all of them is given. You can see here the strongest reducing agent here. Reducing agent means it will reduce others, itself it has to undergo oxidation. Strongest oxidation, if it is undergoing, the reduction potential should be least, then oxidation potential will be higher. So whose reduction potential is least here? You can see that, yeah, Zn reduction potential is the least one, means Zn will having the less tendency to undergo reduction, that means it has more tendency to undergo oxidation. So if Zn is undergoing oxidation, then it will behave as a strongest reducing agent, that is option number A here. Yes, Nagaraja has also given. Okay, go Gnings, which question you want me to explain again? Please tell me. Question number 3 or 2. Go, please put down in the comment section. I will explain again. Okay, just tell me which question you want me to explain again. Next, nickel cadmium cell. What is the final reaction of the cell that is being asked? Okay, so final reaction you have to remember, that is nickel plus we get here, yeah, the first one, cadmium plus nickel oxide plus water gives cadmium hydroxide plus nickel hydroxide. Yes, option number A is correct here. Next, moving to fifth question, which of the following statement is correct regarding the variations of molar conductivity with concentration? Molar conductivity decreases with decrease in concentration? No, molar conductivity increases. Variation in molar conductivity of weak and strong electrolyte is same? No. Molar conductivity increases with the decrease in concentration? Yes. When concentration of the solute approaches 0, the molar conductivity is known as conductance? No. Okay. 5C is correct. Okay, Gins has said me to explain the second question once again. Let me do that first. Okay, please see here. Second question I want to explain once again. There are some students who are having doubt here. So please listen. The first is saying Zn and Fe. Okay, suppose in one container you keep Zn2 plus, okay, and you have Fe2 plus. Now if you observe that Zn2 plus, just a minute. Okay, now if you observe Zn2 plus reduction potential is higher, right? Zn2 plus, if you observe this one, Zn2 plus and Fe2 plus. Fe2 plus reduction potential is higher, that means what? Fe2 plus will undergo reduction. Okay, now if Fe2 plus is undergoing reduction, then the other one Zn has to undergo oxidation. So what will be the reaction here? Zn will undergo actually oxidation and Fe will undergo reduction. Okay, now if Fe is undergoing reduction, it will behave as an oxidizing agent. If Zn is undergoing oxidation, it will behave as a reducing agent, right? So Fe2 plus will oxidize Zn and Zn will reduce Fe2 plus. So that is what is given in the first option. Zn will reduce Fe2 plus. So that is why option number A here. Okay, I hope this is clear. Okay, let's move to Now we will be moving to 3-marker questions directly. So the sample question paper 1 of 2025, there was one question that is asked again and again. Direct measurement of conductivity of ionic solutions by Wheatstone bridge is not possible. Give reasons and suggest a remedy to it. So the first one here is, in Wheatstone bridge we use direct current, and what is the problem with this direct current? Direct current can actually change the composition. Okay, that's the first thing. Second thing, solutions. These electrolytes are solutions, right? It is not a resistor that you can connect it with wires. So the solutions cannot be connected to the bridge. So what are the solutions for that? These are the problems. What are the solutions? Instead of direct current, you can use alternating current. That's the first thing. Second, you cannot take solutions directly. So there's a particular cell that is developed for that, that is called as conductivity cell. So in conductivity cell, you can take the electrolyte and can then measure the resistance of that. So electrolytic cell is connected to Wheatstone bridge by using conductivity cell here. That is the solution here. Okay, thank you, Gins. Let's move to the next question. Faraday's second law and 2 factors on which the products of electrolysis depends. So second law, all of we know. What does it tell? When you pass equal amount of current to the batteries connected in series, the mass deposited is proportional to their equivalent weights, right? So the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Yeah. So we have this formula for Faraday's first law, M1 by M2 is equal to E1 by E2, right? Next we have products of electrolysis depends on nature of the material and the type of electrode being used. Okay. Next question, we have plot a graph for molar conductivity versus concentration of strong and weak electrolyte. For strong electrolyte, write the equation. Okay, so what is the graph? We have studied this graph again and again. For weak electrolyte, the graph is like this. Strong electrolyte, the graph is like this. The equation here is called as D by Huckel-Onsager equation. So just let me write down for you. D by Huckel-Onsager equation. Lambda m is equal to lambda naught m minus A root over of C. Next we have, during the working of a Leclanche cell, write the anodic and cathodic reaction. What is the role of ammonia produced during the cell reaction? Okay, so dry cell, anode reaction and cathode reaction you have to remember. Then what is the role of the ammonia produced? The ammonia that is produced here actually forms complex with Zn2+. Okay, the ammonia produced form complex with Zn2+. Next, sample question paper 3, name the fuel cell that was used in Apollo space program and write its anodic and cathodic reaction. So what was the fuel cell that was used in Apollo space program? Hydrogen oxygen fuel cell. Okay, cathodic reaction, oxygen will undergo reduction, anodic reaction, hydrogen will undergo oxidation. Okay. Next we have mentioned any 3 thermodynamic properties that can be determined using the electrochemical cells. So here we have Gibbs free energy, enthalpy change and entropy change. These are the 3 thermodynamic quantities. Next, there was a question in 2025 paper that neat level diagram of SHE. So you have to draw this diagram and then you have to write the notation and the overall equation of the cell. Okay. Next, again in 2025, there was what is a secondary cell and write down the reactions at anode and cathode during the lead storage battery. So what is the secondary cell? The secondary cell is a cell which can be used again and again after passing current, or which can be charged again by passing current in opposite direction. Now anodic reaction is Pb getting converted to PbSO4, cathodic reaction PbO2 getting converted to PbSO4. Okay. Next, we have in midterm 2024, there was a question, 3 differences between metallic conductance and electrolytic conductance. So you can write here, in electrolytic conductance, who carries electricity? Ions. In metallic conductance, the free electrons carry electricity. Depends on temperature. How electrolytic conductance depends? It increases with the increase in temperature. Here it decreases with the increase in temperature. Next, it depends on the electrolyte concentration. It depends on the number of valence electrons per atom. Okay. Next part, For the dry cell, write the anodic reaction, cathodic reaction and cell potential that we have already written already. Anode reaction, cathode reaction. The cell potential is very important here, 1.5 volt. Please remember here. Okay. Next, I'll go for some more expected questions that I think is very important from this chapter. Explain the variation of molar conductivity with concentration. So first of all, you have to write molar conductivity increases on dilution. Next, how it is varying for strong electrolyte and how it is varying for weak electrolyte. So that you should be writing. For both strong and weak electrolyte, the molar conductivity increases. But for weak electrolyte, the increase is more. The reason is being what? That because for weak electrolyte, the molar conductivity increases more than for the strong electrolyte. Now, what is the reason here? In weak electrolyte, as you dilute, what happens? The number of ions also increases, right? Due to dissociation, the number of ions increases. Whereas in strong electrolyte, it is because of the increase in the mobility of the ions. Okay. This graph we have already discussed. Next, Kohlrausch's law and some applications of this one. So you can write down what does Kohlrausch's law states. Royston, maths and physics revision is already done. You can check in the channel. Day before yesterday it was maths revision, and yesterday we had physics revision, and tomorrow there will be biology revision. Okay. Okay. So what is Kohlrausch's law? The molar conductance is the contribution is due to the contribution of the ions present in that. Like for example, if you have the molar conductance of NaCl will be equal to the molar conductance of the cation present in it plus the molar conductance of anion present in it, right? That is the what I'll say, this is given by Kohlrausch's law. Now, given it two applications of Kohlrausch's law, it is used to determine the molar conductivity of weak electrolyte, and it is also used to calculate alpha, that is degree of dissociation. Clear? Next question, how much, okay, I want all of you to answer this question. How much charge is required for the following conversion? Okay, so how much charge is required here? Aluminium 3 plus 2, aluminium 3 Faraday, copper 2 plus 2, copper 2 Faraday, MnO4 minus, this is plus 7 and this is plus 2, so that is 5 Faraday. Okay, 5 Faraday here. Next, numerical questions. So just all of you can see the question. I'll not be solving it in detail. I'll tell you how to solve the question. Okay, so you can sit with your calculator and quickly solve with me also. So the first question has given us the molar conductivity of 0.0. So what is the concentration given? 0.025. Okay. Methanoic acid is 46.1 s centimeter square mole inverse. That is the molar conductivity. How much? 46.1. Now calculate the degree of dissociation. You want to calculate degree of dissociation. The given values are this one. So from here I can calculate the limiting molar conductivity. So limiting molar conductivity will be what? 349.6 plus 54.6. Like that will give me 6 plus 6, 12, 9 plus 1, 10 plus 4, 14. I have 404.2 something. And what is the formula of alpha then? Lambda m by lambda naught m. So that is equal to 46.1 by 404.2. Okay, so if you solve this, we will get that. So can anyone tell me the answer for this one? We will be getting around 0.114. Okay, you can check this answer. We will get around 0.114. Let's see the next question. Sample question paper 1. There was this question in 2025. Two electrolytic cell A and B containing the solutions of AgNO3 and copper sulfate respectively are connected in series. A current of 1.5 ampere. Okay, I'm just writing the values that is given. Was passed through them until 1.45 gram of silver was deposited. Mass of silver deposited was 1.45 grams. Then how long did the current flow? You have to calculate for how long did the current flow. And what mass of copper was deposited. So we have to use both Faraday's first law and Faraday's second law here. Okay. So if I use Faraday's first law, what is Faraday's first law? M is equal to Z into I into T. Right. What is Z here? How to calculate Z? Okay, how to calculate Z? Z is equal to molar mass divided by N into 96500, right? So what is Z? What is getting deposited? Silver is getting deposited, right? What is the molar mass of silver? 108. Then for silver, how will the silver deposit? Ag plus 1 electron will give you silver. So N value is 1 here. So N value is 1 into 96500. What is the current value? I have 1.5 ampere. Okay, time you have to check. Time we have to calculate. And what is the mass deposited? According to the question, it is 1.45 grams. Right? So now if I solve this, I'll get the value of T. You can just calculate and let me know. Yes. Okay. So by this method you can calculate T value. Next, what is the mass of copper deposited? We know mass of copper deposited by mass of silver deposited will be equal to the equivalent weight of copper by the equivalent weight of silver, right? So what is the equivalent weight of copper? 63.5 by 2, right? Equivalent weight formula is molar mass by N factor. Copper, how does it get deposited? Cu2 plus 2 electron will give you copper, right? So 63.5 by 2, that is the equivalent weight of copper. Equivalent weight of silver is how much? 108 by 1. Molar mass is 108. So 108 by 1. Now mass of silver deposited was 1.45. So I'll just take this one to this side. So I can just arrange this equation like this. Mass of silver, if I multiply this side, that is 1.45. Now if I solve this, I'll get the mass of copper deposited. Okay, so Rasan has already given me the answer. Yes, so mass of copper deposited is 0.42 something, and the time, the first part, the time is 864 seconds. Okay, let's move to the next question. Here, the electrical resistance of a column. So you have resistance given. So the electrical resistance of a column of so concentration is 0.05 mole liter inverse. Diameter given is 1 centimeter. Okay, area given is 50 centimeter. Okay, not area, sorry. Length is 50 centimeter, diameter is 1 centimeter, resistance is 5.55 into 10 to the power of 3 ohm. Calculate its resistivity, conductivity and molar conductivity. Okay, so first of all, what you can do? Resistivity. Rho is equal to, I have this formula. R is equal to rho into L by A. So what is resistivity? Resistivity is R into A by L. So I'll substitute here R. 5.55. One second. So I'll just substitute. You can tell me, calculate and tell me the answer. Okay. So we will have here 5.55 into 10 to the power of 3. Okay. Now area here is the tricky part. This is diameter given. So what is radius here? Radius is 0.5. So I have area formula is pi into r square. Okay. For place of pi you can substitute 3.14. Divided by length given to me is 50 centimeter. So calculate this and tell me how much I'll get. Resistivity, how much I'll get. All of you, please do this calculation and tell me how much I'll get the resistivity. Anyone has calculated the resistivity? Tell me. Okay. I will tell you. So after you calculate this resistivity, the next part is conductivity. So whatever value you get here, let it be X. Okay, just once you tell me, I'll put the value 87.135. Okay, so 87.135, I have got the answer from Rosen. Other students also please verify if you all are getting the same answer. So how will be conductivity calculated? 1 by rho is conductivity. So 1 by 87.35. Okay. 87.135. Okay, so that is your conductivity. Now next thing is to calculate molar conductivity. So molar conductivity is what? Kappa into 1000 by C. So kappa value is what? 1 by 87.135 into, I have 1000 here, and the concentration is 0.05 So if I substitute everything, I'll be getting the molar conductivity value. So here I have taken the values in meter, so there will be slight difference. So you can definitely get this one for 0.00, I'll go to 114. Yeah, you'll get this one for 0.01148, and this one you will get for 229.52. Okay. S centimeter inverse, molar conductivity will be S centimeter square mole inverse. Okay. Now let's, okay, yes, very good, Rasan, you are getting all questions correct. Next, sample question paper 2, there was a question, calculate the Gibbs free energy and the equilibrium constant for the cell reaction. Okay, so you have seen this reaction, you can see that Fe is undergoing reduction and I is undergoing oxidation, right? So this is cathode, this is anode. So what is E naught of the cell? E naught of the cell is always E naught of cathode minus E naught of anode, right? So what is the value of cathode? Fe3 plus is my cathode. So 0.77 minus 0.54. Okay, 7 minus 4 is 3, 7 minus 5 is 2. 0.23 something I'll get. Cathode minus anode, yes. So this is E naught of the cell. What is delta G formula? Minus NF E naught of the cell. So N value here, if you see, plus 3 to plus 2, 2 electrons are in, means 1 electron is involved, but 2 Fe is there, so N is 2 here. F is 96500, E naught is 0.23. If you solve this, you will get the value of delta G here. Okay, so just calculate and tell me how much we'll get for delta G value. Next question is, for once you have found out this delta G, you have to find the value of K. So minus 2.303 RT log of K here. Okay, so you can just put the value delta G, whatever you have got, minus 2.303, R value is 8.314, temperature is 298, and then log of K. Okay, this value you would have already got here. You need to substitute here and then take the anti-log and you'll get the K value. Okay. Yes, so once you solve this, you will get 44 minus 44 I have got, just check this one, you will get minus 44.3 kilojoule per mole, and this value will be log K value, or K value will be something to the power of 10 to the power of 7. Okay, I'll tell you how much you will get exactly. Yeah, 9.594. Yes, that is correct. Rasan, you have given correct answer here. Okay, let's move to next question from sample question paper 3 here. Calculate the EMF of the falling cell and state whether the cell is feasible or not. So in that question, if the E naught value, if your E naught value is positive, then the cell is feasible. Otherwise, it is not feasible. So you can just calculate using the Nernst equation what is the EMF of the cell. So here you see bromine is undergoing oxidation, -1 to 0. Bromine is undergoing oxidation. H plus is undergoing reduction. So what is the reaction at anode? At anode, what is my reaction? At anode, what happens? Br minus is getting converted to Br2. I can write like this. Okay, and what is the reaction at cathode? At cathode we can write like this. Okay, now I can add both the reactions to get the final reactions. 2 Br minus plus 2 H plus, 2 electrons will get cancelled. We will have Br2 plus H2. Now Br minus concentration is given 10 to the power of -2 molar, and H plus concentration is given as 3 into 10 to the power of -2 molar. Okay, now we can write the Nernst equation. Before that, we also need to calculate E naught of the cell. That will be E naught of cathode minus anode, right? So cathode is hydrogen whose value is 0, and anode bromine is 1.09 volt. So that is minus 1.09 volt. Okay. Now what I can do, I can just substitute in the Nernst equation. E of the cell is equal to E naught of the cell minus 0.059, N value is 2, log of What are the ions present in the product side? There is no ion in the product side, so I can just simply put 1 divided by the ions present in the reactant side. So Br minus concentration, the coefficient is 2, and then H plus coefficient is 2. So I will just substitute all the values here. So I have minus 1.09 minus 0.0592, okay, log of 1 by, this is 10 to the power of minus 2, so it becomes 10 to the power of minus 4, and this will becomes 9 into 10 to the power of minus 4, right? If I square this one, it will become 9 into 10 to the power of minus 4. Now if I just solve this, you will get the value of E naught, which will be equal to minus 1.3 volt. Now since this is a negative value, so what about the feasibility? I can say that cell is not feasible. Okay, cell is not feasible. How 44.3? Okay. Dear, just let me see the calculation. 1 second, just give me 1 minute. So we have this value, right? I'll just calculate it. We have 2 into 96500 into 0.23. Yeah, if I multiply this one, I'll get 44.39. Okay, so that is what is the answer, because you have n value, I have taken 2, right? Then 96500, E naught of the cell is what? E naught of cathode minus anode. Since Fe is undergoing reduction, that is cathode, so 0.77 minus 0.54. So that will give me 0.23. So if I multiply, I'll get minus 44.39. Okay. Raisen, just check this one. You will get this calculation. Okay. Fine. So with this, we have now completed the electrochemistry chapter as well. Now let's move quickly to the last chapter, that is solutions chapter. Okay, we'll discuss it quickly. I know all of you are hungry, and yes, so let's start with the solutions chapter. First, I'll be discussing the 1 marker question. Okay, so now we have entered to the solutions chapter. Okay, yes, so now please answer this first question. Which of the following statements given below concerning the properties of solutions describe a colligative effect? Okay, so vapor pressure of a pure water decreases by the addition of nitric acid. See, that is definitely a correct statement, but not because of colligative property here. Boiling point of a pure water decreases by addition of water. No, boiling point always increases. Boiling point of pure benzene increases by the addition of toluene. Yes, we know there is a colligative property, which is elevation in boiling point. Okay, next let's see the next question here. The molar solubility of helium, nitrogen and oxygen are plotted against the partial pressure of the gas at constant temperature. So Henry's law constant for these gases will lie in the order. So if you see, how can you find this value? So if you have a particular pressure, okay, if I consider this particular pressure, at that we have 3 different solubilities, right? So oxygen is having highest solubility, helium is having least solubility, and nitrogen is having moderate solubility. So the one which is having highest solubility will have least KH value. So oxygen will have least, then helium will have highest, and nitrogen here. So option number B here. Next we have pi 1, pi 2, pi 3 and pi 4 are the osmotic pressures of 5% solutions of urea. The correct order of their magnitude is. So if you see here, what is the formula of pi? We have C into R into T. What is C here? Molar mass divided by N. One second. How can I write the formula of C here? C is what? Given mass by molar mass, right? So now if molar mass is more, pi value will be less, and that is what you have to understand. So we have first one, urea. Urea molar mass is 60. Then you have fructose, whose mass is 180. Then you have sucrose, whose mass is 342. Then you have KO, whose mass is 39. Okay, KO is again here, KO will ionize, it is an electrolyte solution, so it will have an I value. So KO value will be highest definitely, pi 4 will be maximum because your I value is 2. Now after that we will have the one which is having less mass, so that is urea, pi 1. After that we will have pi 2, then pi 3. So option number C here. Okay, C will be the correct answer. Next question, the mixture shows positive deviation from Raoult's law, undoubtedly ethanol and acetone. We know this very common example. Now let's move to some 2-marker question here. There are some basic questions that you should know. What is Henry's law and its significance? So definition and all. So I'm not going to explain this. You just need to know what is Henry's law. It states that the solubility is directly proportional to the what? To the gas or to the pressure present above the liquid. Then what is its significance? Higher KH value means less solubility. 2 applications of Henry's law. 3 applications are given in the book. You can write any 2. First is the packing of the carbonated drinks. Second is the scuba diving. They have helium in their oxygen tanks. And third one is the altitude. At high altitude we have what? Bend's problem. That one. Sorry, anoxia. So 2 applications you should be knowing here. Just a minute. Okay. Now let's see the next question. Raoult's law and its mathematical formula. The same thing you should know. What is Raoult's law? That the partial pressure is directly proportional. For any solution, the partial vapor pressure is proportional to the mole fraction of the solute in the solution and its mathematical form. State Raoult's law as applied to a binary solution of a non-volatile solute in a volatile solvent. So how the graph looks for that? So when you add a non-volatile solute, the solute will not evaporate, right? Only the solvent will evaporate. In that case, what will happen? The vapor pressure that is created is only because of solvent. So the total pressure is equal to pressure of 1. So if I have 2 components, okay, A and B. A was the solvent, B was the solute, and now B is non-volatile, so it will not vaporize. So whatever vapor is created here, P total will be equal to PA only. PB is not there, pressure of B is not there. One second. Yeah, pressure of B is not there. Why? Because it is non-volatile. So what I can write? So PA is proportional to PXA, or you can write it as PA is equal to P naught A XA. Okay. Next, moving to write the mathematical relation between molality and depression in freezing point. So molality and depression in freezing point, delta TF is equal to KF into M. All the terms you should be mentioning. Why is sodium chloride is used to clear the snow on the roads? So when you add some sodium chloride, what happens? The melting point decreases. So the ice can no longer be solid at that temperature. So it also melts and immediately the road is cleared here. Next we have some reasoning questions. Cutting onions taken from the fridge is more comfortable. Why? Because as compared to the onions that is already present in the room temperature. Okay, so what is the reason here? The first one is when onions are taken from the fridge, they are less volatile, so that the chemical that it produces from the onion is less, so that is why it is more comfortable. And fruits and vegetables, they have dried, and when you put them back into the water, it swells again. Again, the reason here is that is because of endosmosis. When you put it in water, it gets osmosis takes place, and that is the reason here. Next, we have draw a graph to show the variation of vapor pressure of solvent with respect to temperature. So this graph you can draw solvent and solution. Solution vapor pressure will be less than that of the solvent. Okay. Okay. Next, we'll go to 3-marker questions here. So in 3-marker questions, mostly you have to focus on the difference between questions. So the first question is the ideal and non-ideal solution. Here I have given the points, just you can note it down. Obeys Raoult's law, does not obey, delta H mix, V mix, interactions, and then examples. Next you have about positive, ideal and non-ideal solution. Then we have positive and negative deviation. Same, the interactions, total pressure, delta H mix, delta V mix. This is very important, where you have to note down the examples properly. Okay. Next, you have azeotropic mixture, that is azeotropic mixture of maximum and minimum boiling azeotropes. First of all, what is an azeotrope? That you have to explain. That is, it is a binary solution where the composition in the liquid phase and the vapor phase is same. That is the definition. Next, the examples of maximum and minimum boiling azeotrope. Maximum boiling azeotrope is shown by negative deviation. Minimum boiling azeotrope will be shown by positive deviation. And next, these examples are important. Next, we have something that is about osmotic pressure. So what are the 3 reasons that osmotic pressure is considered as the most important method to calculate the mass of the macromolecules? This was a question in the sample paper as well. So there are 3 reasons that you should be knowing. That it gives you first appreciable values, it can be measured at room temperature, and it provides greater accuracy. Okay, these are the 3 things. Next, we have desalination of water by reverse osmosis. You can explain in this way. Reverse osmosis is used in the desalination of seawater. When pressure more than osmotic pressure is used, at that time what happens? Water flows in the opposite direction and we get pure water is produced here, and the semi-permeable membrane that is used here is called as cellulose acetate, and this diagram you can draw here. Okay, so now we will quickly move towards this question that was asked in half yearly of 2024, that 1 mole of sucrose is added, then why the vapor pressure decreases. So we all know that when we add a solute, so earlier suppose the whole surface was covered with solvent molecules. Now when you add a solute, the solvent particles move out and we get a solute particle. Some of the surface particles are occupied by the solute particles. So as a result of which there will be less solvent particles now to evaporate, and that is why we get what? Less vapor pressure is created. Next, why do phenol, I'll show you how to write also. Next, why do phenol and alanine shows negative deviation? That is because of intermolecular hydrogen bonding. Vapor pressure of 1 mole of glucose is less than that of the pure water. The same thing again, when you add a solute, it actually decreases the vapor pressure. So I'll show you here. Yeah, so you can see here that when you add a solute, what happens? The vapor pressure decreases, and in phenol, why there is a positive deviation? That is because of bonding. Next, we have what do you mean by isotonic solutions? 2 solutions having same type of osmotic pressure is called as isotonic solutions. Example is 0.9% NaCl solution. It is isotonic with blood. Now we'll quickly discuss some of the numericals. Okay, so first of all, there's one question. 450 centimeter cube of an aqueous solution of a protein contains 1 gram of the protein. The osmotic pressure of such a solution is given to you. Calculate the molar mass of the protein. R value is given already. Okay, so now how to do? So you can see what is the formula of pi is equal to CRT, right? All of you can do this calculation and tell me. Pi I can also write now given mass by molar mass into 1000 by volume into R into T. Now what is the value of pi? 3.1 into 10 to the power of minus 4 bar. Okay, what is the mass of the solute added? We have 1 gram. Then molar mass we have to calculate 1000. Volume is 450. R is 0.083. Temperature is 310. Now if I solve this, I can calculate the value of M here, right? So how much I'll get that one? If I calculate this, I'll get around 1,84,444 gram per mole. Next, we have another question from depression in freezing point concept. So you have weight of 1 gram, okay, and non-electrolyte dissolved in 50 gram of benzene. So this is weight of solute. WB I'll write. WA is how much? 50 gram of benzene. Load the freezing point. So delta TF you have 0.4 Kelvin. Okay. The freezing point depression constant KF is 5.12. Next, you have to calculate the molar mass of the solute. Now, if I just calculate this one, delta TF is equal to KF into mass. given mass by molar mass into 1000 by mass of the solvent. Okay, so if I just solve this, what is delta TF value? Delta TF value is 0.4, KF value is 5.12. Now W is 1, this is MB, I have to calculate, into 1000 by 50. Now I just need to solve this and calculate the value of MB, which will be almost equal to 256 gram per mole. Okay. Okay. So students, now if I see, I have completed all the chapter questions. We have done a revision. Okay, so I'll be sending you this PDF, so you can just use this PDF and re-revise the questions. Okay, so that's all in this session. Thank you so much, my dear children, and just if you have any doubt in any of the questions, you can put down in the comment section. I'll definitely address to it. So thank you so much once again, and all the best, and just subscribe the channel. We'll be bringing many more such videos. Okay, thank you.